Morning. Hello. Good morning, guys. In about next 16 to 17 classes, we will discuss topics of science and technology. Before I jump into the topics, I have few very basic things which I wanted to talk about. Let's start with relevance of this topic for prelims and mains examination. In prelims, you can expect about 10 to 12 questions. Minimum 10 you can easily expect, maximum 14 also, but on an average about 12 questions in prelims examination. In mains examination, you can expect about 3 to 4 questions. If you look at your main syllabus, then mains का जो syllabus है बहुत defined है, like clear keywords are given. If you look at the prelims syllabus, there is just 2 words, general science, that's it. Nothing else is written. The word general science is mentioned. So prelims has a very open-ended syllabus, but mains has some dedicated keywords, and that makes it perhaps little bit better, that you know what you have to study. But in prelims examination, because of this open-ended syllabus, UPSC also asks questions from any of the topics. So this is about relevance of this topic. I also think this is one of the most doable topic. This is one of the most scoring topic, particularly in prelims examination. And at the same time, I also know that a lot of students fear this subject, because you haven't studied science after class 10th or after class 12. And then there is this inherent fear that this is very difficult, or technically this is a complicated topic, which you do not have to. So let me start this entire discussion of science and technology by making a very simple statement that you'll have to work a little bit harder, that's it. But you can easily attempt 80 to 90% of the questions from this topic, because questions will not be factual, questions will be analytical, they will be logical, and they will be very much attemptable. So if let's say for example, if there are 12 questions, I do think all of you have potential to attempt 10 there and get 8 to 9 correct also. Because questions are not factual. And the moment you decided that you are going to prepare for UPSC, I do hope that you had faith in your aptitude. So again, I am asking that have faith in your aptitude and work hard. It will not be easy. It should be very clear it will not be easy, particularly if you do not have a background. But you'll have to spend some more time. But the thing is that once you understand a particular concept, you do not have to think about that I need to go and memorize it. You do not have to do something like that. Just a clear brush up of concept will be more than enough to revise this topic. So maybe the first go, the very first study, the very first time you are studying a particular topic, it may be difficult or it may take some time, but the revision will be very easy, and that is why I'm saying that this is one of the most scoring areas for both prelims and mains examination. मेंस और भी ज़्यादा सिंपल है. प्रीलिम्स मुश्किल इसलिए है बिकॉज प्रीलिम्स का सिलेबस बहुत ओपन एंडेड है, बट मेंस का सिलेबस जो है वो वेल डिफाइंड है, एंड मेंस के क्वेश्चंस और भी सिंपल हैं, बहुत सिंपल होंगे. I also want you to apply a simple thumb rule as we study, that I'm going to discuss, of course, many topics in this entire discussion of science and technology. But whenever you are coming across a new topic, I expect you to do few things, not a lot of things, very few things. I expect you to define a particular concept or a particular technology into not more than, let's say, 30, 40 words. That if I ask you, let's say, what is blockchain technology, then can you tell me in 30, 40 words what is blockchain technology? That is the first thing I want you to do. The second thing I want you to do is that I want you to understand how a particular domain of technology has applications in various areas. So focus a lot upon the applications part, that what it will lead to, or what type of applications it has in different areas. The third thing which you have to do is that almost all technologies will have some limitations. They will also pose some challenges. So know about those limitations and challenges as you go ahead in your study. And the fourth thing which you have to do is that if you know something Government of India is doing, if Government of India is doing something in a specific domain of technology, then definitely know that. Even if it is not doing something, other three parts you have to remember, you have to know that you know what the technology is all about, you know its applications, all the possible applications, you know its limitations and challenges. And if you can follow even this framework, you can answer most of the questions, if not all of them. This very simple framework which you have to adopt in this entire discussion. The second thing which we should discuss here is that what should we refer to? Like what are the areas, what are the books and other sources we should refer to? So I do not recommend any book per se except NCERT, and NCERT only to brush up your basic concepts. So I do expect that you go and read 7th, just to brush up your concepts, whatever you already have studied in your school days. I just want you to revise those things. Because going ahead, I will be using a lot of terms, and I will expect that you know of those terms, simply because those terms you have been taught in your school days. For example, I will use the word momentum or potential energy, and I expect you to know that what am I talking about. So just in case if you are forgetting about these things, and that is why I am saying that, go and brush up your concepts from 7th, 8th, 9th, 10th NCERT. There may or may not be a question from this NCERT. That's not the point. The point is that you will be able to understand scientific concepts in a better way once you have all these terminologies and basic concepts are clear from physics, chemistry, or biology. Apart from that, for me the primary source is the Hindu. Indian Express in recent years, they have improved their science and technology coverage a lot. So you can refer to Indian Express also. Hindu has a better coverage of science and technology, without a doubt. The problem with Hindu though is that it goes into a lot of detail of things. And that may lead to this fear that itna detail mein jana bhi hai kya? One of the things which aspirant always suffer from, that itna detail mein padhna bhi kya, particular topic ko. And in most of the cases, the answer will be no, that you do not have to go into a lot of detail. You should understand the basic concept, the applications part, but you do not have to go into a lot of detail. But nonetheless, Hindu definitely has a better coverage of science and technology. Indian Express in last 3-4 years have improved their coverage a lot. So particularly those areas which are covered in editorial or explained pages of Indian Express, definitely read that. And same goes in case of Hindu. Hindu also has its own explained page. On Sunday particularly, they have this dedicated focus on science and technology. So definitely read that. And you can also refer to, in general, whatever they are covering from technology. Daily bhi aapko mil jayega. So use these 2 newspapers. How to read that? You do not have to read both of them completely. Just read one. And the other, just focus on the explained and editorial page. That's it. Right? So for example, if I am studying the Hindu, then I will try to also cover the explained page of Indian Express and editorial page of Indian Express. For me, these are the 2 primary sources. Apart from that, just before prelims examination, students will come and say to me, ask me that, sir, ये तो Hindu पढ़ा नहीं, अब क्या PT 365 पढ़ ले क्या? ये जो monthly magazine है पढ़ ले क्या? बिल्कुल पढ़ लो. मैं आपको मार्च में थोड़े बोलूँगा कि अब जाके हिंदू पढ़ो पिछले साल भर का. I will not say that. So for me, I'm very clear about one thing, that for me the primary sources are newspaper reading by yourself, and try to minimize the ready-made content. What do I mean by ready-made content? That even Vision IAS has this daily news analysis. आता है ना, हर दिन daily news analysis आता है. बहुत सारे institutes हैं, they have this daily news analysis. They have weekly focus. They have monthly magazines. Vision IAS का monthly magazine बहुत famous है. All of that is a complementary material. It should complement your primary newspaper reading. It shouldn't be taken as a primary source. So I'm very clear about this particular thing, that try to read newspapers, spend about 1.5 hours to 2 hours, but try to take newspaper reading very, very seriously. Right? So ये बहुत important है. In the initial days of your preparation, I still will accept that you are trying to focus on some compiled material, because a lot of topics you do not have background, and perhaps when you read something from magazine, they will try to give you background, and maybe that will be helpful. But as you study, as you get to cover more and more of your topics, then I definitely want you to read newspaper by yourself, right? So in newspaper reading inculcate करना preparation में बहुत ज़रूरी है. And by the way, it is not just important for science and technology. In general, it will help you a lot in your preparation. So for me, I will keep repeating this: newspaper reading all by yourself. That is primary source. There are other sources, of course. You can जो monthly magazine है, आप कोई भी magazine उठा लो, but just pick one. Do not suffer from FOMO. That fear of missing out will not be good thing here. That कुछ लोग किसी और institute का पढ़ रहे हैं, क्या पता उसमें कुछ और हो, Vision IAS में ये नहीं है, things like that. कोई भी एक उठाना है आपको. Pick any one magazine, but stick to that only. Do not try to diversify your sources a lot, right? So though newspaper I am recommending, and just any magazine, any monthly compilation of things, you can refer to Vision IAS monthly magazine. It has a very good comprehensive coverage. There will be classes also of those monthly magazine. अभी से शुरू नहीं होंगी, अभी तो अप्रैल है ना. So I think in the month of July or August, your monthly current affairs classes will start, and for each and every topic there will be dedicated classes, but that will be only online. It will not be offline classes, online live classes though. So I highly recommend that if you are reading a magazine, and if you can understand a particular topic from all by yourself, then very well. But if you cannot, then definitely you can attend the classes also, live classes or recorded classes. Definitely go and attend that. I think it will start from April or May magazine, right? या तो April का magazine होगा या May का magazine होगा, वहाँ से आपकी monthly current affairs की classes भी शुरू होंगी. So monthly magazine, but that is a secondary material. It's not a primary material. It should complement what you already have studied from newspaper. It shouldn't be the primary source of your preparation. And use ChatGPT as much as you can. How many of you do not use ChatGPT? So make ChatGPT your new best friend. Make an account. जो ChatGPT, particularly GPT 3.5 जो है, I will be talking about AI. I will be talking about generative AI in more detail in subsequent classes. But learn to use ChatGPT and use it as much as possible. Okay, I will be talking about this entire concept of generative AI in subsequent classes. So make an account if you already do not have one, and इसको use करने का तरीका simple है. कोई भी जब आप एक और GPT 3.5 जो है free of cost है, तो उसके लिए कुछ subscription लेने की ज़रूरत नहीं है. GPT 4 is expensive, but GPT 3.5 and that is more than enough by the way for preparation. So what you need to do, make an account. Whenever you ask a new question from it, it makes a tab. Side में left hand side में एक tab बना देगा. So just go and rename that tab. Rename का option होगा. And from that particular theme, from that particular topic, ask question in that tab only, so that you have also get to have a very good repository of all of the questions which you have asked. So that can be very helpful. You can make a tab for polity, economy, science and technology, or whatever. So use ChatGPT in your preparation as much as possible. It will be helpful a lot in your optional preparation. It will be helpful a lot in your GS preparation. So जितना आप use कर सकते हो, try to use it. This is about sources. I will repeat. The very first NCERT textbook, I highly recommend those who haven't studied science after class 10th and class 12th. I highly recommend that you please go and read that. And even if you do have science background or engineering background or medical background, still I want you to brush up that concept, although for you it is optional. But people who haven't, it is mandatory that please go and brush up your concept. So this is first two things. Relevance of this topic, science and technology. And second is what sources you have to refer to. The third thing, that how I'm going to go ahead with this entire topic. So in today's class itself, I'm going to start with space technology. I will talk about nuclear technology. I will talk about nanotechnology. I will talk about information and communication technology. There I will discuss a lot of things. about defense, about intellectual property rights, which is given in your syllabus, main syllabus. This is also given in your main syllabus, contribution of Indians in science and technology. Robotics we will discuss with ICT itself. One very important area which I am not going to discuss is biology and biotechnology. For that you'll have separate classes. वो separately discuss होगा. जो biology and biotechnology particularly बहुत important है. तो जो biotechnology है, I'm not going to talk about biotechnology, but rest of the topics I'm going to discuss here. I want you to ask as many questions as you can. I do not get frustrated. It should be very clear that you have to ask as many questions as you can. We are here to learn. If I know the answer, I will tell you. If I do not know the answer, maybe we both will get to increase our knowledge, enhance our knowledge. But ask questions, no matter how mundane or how simple it sounds in your mind, and you think that nobody else is asking those questions, maybe other people will judge me. So what? First of all, nobody is judging you. And second of all, even if somebody is judging you, how does that matter? Right? So ask as many questions as you can. You can ask questions during the class. If you feel more shy, you can ask after the class. I'm available. So, but ask questions, right? So clearing your doubt, that is very, very important. But wait for a topic to be completed. I will give you time. I will give you ample of time. Once I complete a topic, I will specifically tell you that now you can ask questions. So do not interrupt in between when I'm discussing a topic. Maybe a lot of your doubts will be cleared as the topic gets completed. But once I complete the topic, I will give you ample of time to ask questions. And that is what we have to do in this particular. In fact, you should do that in all the subjects. But in science and technology, doing that is very, very important. Okay? So let's start our today's class. I'm going to start with space technology, the very first topic I'm going to start with. Before that, I have a question for you, that we are using two words here, science and technology. I'm going to add one more word, engineering. How many of you are engineers here by education? Good number, right? So let's first try to distinguish between these three words. That what do I mean by a clear definition before we go ahead in any topic is very important. That having a clear definition of things is very important. So let's start. Let me ask you a question, that how does these two terms, science and technology, are different from each other? And where does this word engineering fit into this entire discussion of science and technology? There is a question here that I have used ChatGPT for a month. There were mistakes in content, so afterwards trust issues are developing. How to resolve it? Okay. For factual details, do not rely upon ChatGPT. जहाँ पे भी conceptual clarity चाहिए, आपको जैसे optional में आपको किसी मान लो PSIR आपका optional है. You want to understand more about the writings of a political thinker. You can rely on ChatGPT for that. It will give you good content. You have to, of course, make it more crisp and more concise. But if you are asking questions about, let's say, contribution of agriculture in India's GDP, there is a chance that it will make mistakes or it will not be an updated data. So for factual details, there will be some errors, right? Even for, in fact, I have realized that even in historical facts, it makes error. So when you are, let's say, particularly for history, you are trying to know more about, let's say, ancient history or modern history or medieval history, it makes errors. So yeah, that part I totally accept, that it can make errors. So do not rely upon the factual part, but the conceptual part, the analysis part, you can rely upon it a lot. Yeah, use Gemini also. I do not have anything against Google. Use Gemini also. Gemini is another AI tool, which is, उसके भी 2-3 वर्जन है. जो उसका एडवांस्ड वर्जन है वो सब्सक्रिप्शन बेस्ड है, बट जो उसका बेसिक वर्जन है वो फ्री ऑफ कॉस्ट है. So you can use Gemini also. Gemini is AI tool developed by Google. ChatGPT is AI tool developed by Microsoft. OpenAI is as of now part of Microsoft. we'll be talking about that. Okay, so let's start. I had a question here that how does these two words, science and technology, are different from each other? And where does this word engineering fit into this entire discussion about science and technology? Language is not a barrier, but I do only know Hindi and English. So if you have to say something in Hindi, you can easily say that. Language is not a barrier. And even if you have to ask a question in Hindi, you can totally go ahead and do that. But nonetheless, if you do feel difficulty in English, then I want you to work upon it. Ask questions in Hindi, that's totally fine. But since you have decided that you are going to attempt this paper in English medium, then I also want you to work upon it. You know that this is a challenge, this is a limitation, and you get to work upon it. So let's start this discussion, that how does these two words, science and technology, different from each other? Anyone? Okay, can you elaborate more upon that? Perfect, that's a very good example, and you are right, you are absolutely right. Anyone else would want to add more into this difference between science and technology? सही, उन्होंने भी सेम बात बोला था, साइंस जो है थ्योरेटिकल है, बट ऐसा जरूरी नहीं है कि साइंस खाली थ्योरेटिकल है. सो ये भी एक बहुत बड़ा मिसकंसेप्शन है अबाउट साइंस कि साइंस थ्योरेटिकल है. साइंस कहीं से थ्योरेटिकल नहीं है, साइंस बिल्कुल प्रैक्टिकल है. इनफैक्ट विदाउट बट I guess what you are trying to say is that technology has practical applications. That is, I think, what you are trying to say. But I want more. In fact, forget about the word technology. Let's try to understand the meaning of the word science itself. I feel that we do not appreciate the meaning of word science really well when you are studying in your school days. That these two words you will come across a lot, science and scientific method. So what is scientific method and what science aims to achieve, and how does it aim to achieve that? So let's try to answer this question first. That what science aims to achieve and how does it aim to achieve? That is very important. What it aims to achieve is very simple. It aims to understand how nature works. If I have to define science, it's very simple. That we are talking about a systematic way of inculcating knowledge. And that knowledge aims to explain nature, the working of nature, be working of nature at very smaller scale, for example, working of atoms, molecules, or nuclei, or elementary particles, or even working of nature at very large scale, things like galaxies and stars and universe all together by itself. So science aims to understand how nature functions, but that is not what is unique about science. What is unique about science is the method it adopts, what we call scientific method. So I want to first talk about the scientific method. That what do I mean by the word scientific method? Yes, go ahead. What type of direction? That is what I want. I want more specific answer. And how is it different from other type of methods which aim to inculcate knowledge? Okay, so we jumped from science. Right now I only want to focus upon the word science. Yes. Okay, now that we are coming to more concrete words, that you should have more objectivity and empirical data to support any type of theories. And those are important words. Yes, go ahead. Okay, that is also a very important point, making predictions. Making prediction is one of the very important part of the entire scientific process. Just a second. Yes, you're saying something. Hanji. Okay, perfect. That's a very good point, yes. Causality, understanding the cause and effect relationship, that is also very good uh, reason why we study science. Okay, so all of you are correct. Let me just summarize what all of you have said here. So science, first of all, starts with humility that we do not understand about nature. We first start with this, we accept this, that we do not understand a lot of things about nature. And then we try to understand that how nature functions. What are the rules? If there are rules and regulations, some laws nature functions from, then we aim to understand it. We further created this specific division within science, things like physics, chemistry, biology, although once you go into higher studies, such divisions does not make a lot of sense. Things become interdisciplinary. Interdisciplinary ka matlab ye hai that you have to apply knowledge of multiple domains to explain a particular thing. For example, the working of cellular level, you need to have good knowledge of physics, that how cells are, how heart is pumping blood. For that, you need to understand physics. So the point here is that we have created these divisions, but nonetheless, despite those divisions, the fundamental goal here is that we start with this humility that we do not understand about things, how they function. We aim to understand it. How do we aim to understand it? We first develop a hypothesis. That hypothesis will try to explain a particular thing, but we should be able to test that hypothesis. This is a very important part of scientific method, that whenever we have developed an hypothesis, then we should be able to test it in some experimental data. That we have some experiment, and in that test, we are trying to test that hypothesis if it is correct or not, right? If the experimental data has confirmed the hypothesis to be correct, then that particular theory will gain a lot of validity. But science will never accept anything as ultimate truth. Science will always leave some doubt. That till now, for example, Newton's laws of motion remain true for millennia, for hundreds of years. But then some things happened and Newton's law of motion also had to be rectified. Right? We also know that Einstein ke jo theories hain, they also require modifications. What will be those modifications, we do not know. But we do know that they are not complete theories. They also require modifications. So science always leaves doubt that till now, this is the most acceptable theory to explain a particular phenomena. What if I find an observation or I discover something which does not fit into this particular theoretical framework? When that happens, then I need to modify the theory. I do not need to find the suitable data. This is where scientific method departs from the typical method which we adopt in our day-to-day life. In our day-to-day life, when things do not go as per our own established ideologies and opinions, then we try to find data which fits into our ideologies. यही होता है ना कि आपका किसी जैसे politics में बहुत ज़्यादा हो गए that you support a particular political ideology. Based on that particular political ideology, some data is presented to you, and that data is telling you that आपका जो ideology है flawed है. Your immediate reaction to that data will be that ये data flawed है. इस data में problem है, there is some problem, it has not been collected properly. We need to find better data. Yes, science also aims to does that. That yes, it aims to find जो भी data collection experiments, it has to occur in as correct way as possible. But nonetheless, scientific method, it fundamentally relies upon that can a theory be verified by experiments. If it cannot, then that theory needs to be rectified. So in science, personal opinion does not matter. Science does not give a damn about what you think how nature should work. It only gives a damn that is your theory verifiable? Is it correctly explaining things which we already observe? And rightly pointed out, every scientific theory will try to predict something. And a good scientific theory should be developed in a way that those predictions, let's say, come out to be true in future. So as more and more predictions come out to be true in future, then we know that, okay, this is a, again, well-developed scientific theory, and that becomes now part of curriculum. We get to read about those scientific theories a lot. All scientific methods, they should be reproducible. What does that mean? That I am explaining, I am saying that, okay, this is how things function. I have published, let's say, a research paper on it. That research paper has been reviewed by my peer groups. But the other groups, other people, they should be able to reproduce the same result based on the same experiment. That is also a very important part, that I am claiming something, but that claim is not verifiable by other group of people. Then I will be discredited as a scientist. Right? So scientific method जो है बहुत ही rigorous process है, does not rely upon personal opinions, relies upon hypothesis which can be verified using experimental data, which can be reproduced into a lab setup, and all of that, that is how we aim to gain more and more knowledge. Science never claims that we have attained the ultimate knowledge. Science only and only claims that maybe we will get the ultimate knowledge by successive approximations. So science aims to approximate, science leaves an element of doubt, and with that element of doubt, with asking questions, it aims to know, come closer and closer to truth. That is what science is, and that is what scientific method is. Very different from how other ways to inculcate knowledge occurs, right? So for example, particularly I often contrast that with religion, that how a lot of religion claim that they know everything about how world functions by, let's say for example, some book, that everything which has to know is, it has to, you can get that knowledge from that book. Science will never accept that. Science will always start with this element of doubt that we simply do not know, but we want to know, right? And that element of doubt is very important in this entire scientific method. Belief का कोई यहाँ पे role नहीं है. Science does not believe in belief. It's that simple as that. Now let's come to the technology part. That what is technology? As rightly pointed out, technology is the practical applications of scientific method. That once we understand how things function, then maybe that understanding will develop or will allow us to develop products, processes, and that those processes aim to make our life easier, hopefully easier. A lot of times it makes our life more complicated. But nonetheless, the goal here is that we do want to make our life simpler and easier. That is what technology. And the engineering is the process. So engineering is a profession, but as well as the process which allows that scientific method to be finally emerging into a product which you can use in your day-to-day life. So engineering, when I use the word engineering, that is basically the process we are talking about. As well as the engineering is also used for profession. So that is how these two words are different. That once we understand how nature functions, then based on that understanding, we aim to develop a technology. I'm going to discuss many technologies in subsequent classes, but in all those technologies, I will first start with the basic scientific process, the basic science which we need to appreciate a particular technology, that how a particular technology functions. And I will do that in the space technology itself. So give this heading, space technology. Are you all right? Again, I will start with some basic concepts of science, which I am very sure that many of you already know. I will be simply revising some basic concepts. I will be talking about a lot of things. I will be talking about history of astronomy here, laws of motion, Newton's laws of motion, the concept of vector and scalar, centripetal force, all of that. But my main topic here will be understanding about orbits around Earth, understanding about types of satellites, and applications, understanding about rockets, and particularly rockets of ISRO, understanding about significant missions of ISRO, some missions in last 2-3 years, we will be talking about it here, but also some upcoming missions, and last but not the least, some emerging trends and significant trends. some of the most prominent missions of NASA, as well as other prominent missions of other space agencies, issue of space debris or weaponization of space, those things we will discuss in the last topic. But my focus will be, ये जो areas हैं, ये in fact सारे important हैं, but जो ISRO के missions हैं, and what India is doing, those topics are more important for prelims as well as mains examination. Let's start our discussion with basic concept. So basic concept part hai, in almost each and every topic, I will not make you write anything. I will not be dictating things. If you want to write, make running notes. So I will be dictating a lot of things. For example, in this particular topic, I will start my dictation from the second topic, orbits around Earth. The first topic, I simply wanted to have a discussion. If you want to make notes, make running notes. So in basic concepts, before I go into the basic concepts, I briefly wanted to talk about the history of astronomy itself. And particularly, I want to start with medieval Europe. I do not want to talk about what was happening in ancient India or ancient Persia, because astronomy as a field was perhaps well developed. In ancient Greek also, by the way, for that matter. So in ancient Greek or ancient India or ancient Persia, astronomy as a field was more developed compared to, let's say, medieval Europe. So I want to talk about medieval Europe. What was happening in Europe in 10th, 11th, 12th century? In 10th, 11th, 12th century, the church was very powerful. One of the prevailing dogma was that Earth is center of universe and everything is revolving around Earth, right? That very much fits into this entire notion that we try to think ourselves as center of the universe. ये हमारा inherent narcissism है. हमको लगता है कि पूरा का पूरा जो ब्रह्मांड है हमारे लिए बना हुआ है. ये पूरा यूनिवर्स हमारे लिए बना हुआ है. So based on that particular religious doctrine, church had become very, very powerful, and anybody who opposed such doctrine, they were given severe punishment. At best, they were given prison sentence. At worst, they were burnt alive also. And I will give you a few examples. For example, Bruno was a great philosopher and a mathematician. Bruno gave a hypothesis that Earth is a planet and there may be many more planets in this entire world, and maybe those planets have their own life. And at this point of time, that was considered a blasphemy. That how can you make a statement that there is life on other planet? Earth had this special place in the entire mythology. So Bruno was burnt alive for saying that. You had Copernicus, a great astronomer. Copernicus made a hypothesis that Earth is actually revolving around Sun, not the other way around. It is revolving in a circular orbit. And Copernicus was thrown to jail for that, for saying that. Thankfully not burnt alive. You had a great scientist named Kepler. So I'm going to talk about three people here, three people in fact. I want to talk about Galileo here, I want to talk about Kepler here, I want to talk about Sir Isaac Newton here. So Galileo, for example, with his own, although he did not discover telescope, but nonetheless he did make his own telescope, and with the help of telescope he further confirmed what Copernicus and Kepler were saying. So Kepler was one of the protege of Copernicus, and Kepler can be thought of as father of modern astronomy, that he made a lot of predictions about movement of planets around Sun, and those even though he did not know the reasons why that movement is there, but he did develop the mathematics part of it, right? So all of us have studied about solar system. You had a question, meanwhile आप कुछ पूछ रहे थे. All of us are aware about this simple model of solar system, where Sun is at the center of elliptical orbits, and planets are revolving in elliptical orbit. So one of the most important thing Kepler did is that he rectified Copernicus' theory. So Kepler ka jo he gave three laws of planetary motion. He had no explanation that why those three laws are there. That explanation was given by Newton. But nonetheless, Kepler gave three laws. I only want you to know the first law. The first law is that planets are revolving around Sun in an elliptical orbit, with Sun being at one of the focal points of ellipse. Right? So that was Kepler's first law of planetary motion In fact, let me write it down. The first law he gave is all planets revolve around sun in an elliptical orbit with sun at one of the foci of ellipse. Not at the center of ellipse, but at one of the focal points. So focus का plural है, that is called foci. Let me explain this. First, let me explain about ellipse. Before ellipse, everybody knows about circle. Circle has this property that center from that distance from center, that is always constant. We call that distance as radius. हम सबने पढ़ रखा है circle के बारे में. Ellipse is this very special shape where even ellipse has a center, but ellipse has two focal points, and those two focal points are more important. So for example, let's call this center at C, but the focal points, let's call them F1 or F2. First focal point and second focal point. An ellipse is a shape where the distance from these two focal points, that sum of distance, let's call this distance as x, let's call this distance as y. So clearly x and y will be different. For example, if I take a point here, then x will be very different from x. Here x will be different, y will be different. At some other point x will be different, y will be different. But x plus y will always be constant. So this is the definition of ellipse, that from 2 points, I'm calling those 2 points as focal points, the distance from those 2 focal points is always constant. Now I'm making an assertion here. That assertion is that circle is a special case of ellipse. So जो circle है, I'm making a statement इसको समझना बहुत आसान है, इसको विजुलाइज करना भी बहुत आसान है. आप एक रबर पैड लो, सर्कल बनाओ, रबर पैड को आप स्ट्रेच करो, एक्सटेंड करो, द शेप विच यू गेट, दैट इज व्हाट इज अ ellipse. And one more way, I have access to all these shapes. I think I should have. Sorry, I do not have access to these shapes here on this board. But I can easily make, from something which is ellipse, I can easily make circle out of it. So what happens in case of circle is that in an ellipse and in a circle, this is center, focal point F1, F2. In circle, all these 3 points come together. All these 3 points coincide. And because of that, this distance x and y, both of that distance becomes r plus r, which is nothing but diameter of the circle, and diameter is constant. So the difference between circle and an ellipse, that in case of circle, the focal points and the center are not different points. All 3 of them are at the same point. And that is why the sum of distance is nothing but 2 times radius, which is nothing but diameter, and diameter is constant. But in case of ellipse, you do not have any radius. What you do have is distance from these 2 focal points, and sum of that distance is constant, even though the individual distances are different. So what Kepler's first law is telling us, that planets revolve in elliptical orbit, and sun is not at the center. Sun is at one of the focal points. That is what Kepler's first law is telling us. What it means is that there will be a point where the planet will be farthest from sun, and there will be a point where planet will be closest to the sun. So in case of planetary motion around sun, this point is called aphelion, and this point is called perihelion. But in general, we use the word apogee and perigee for elliptical orbit. So for example, I'm going to talk about satellites around Earth, and most of the satellites also revolve around Earth in elliptical orbit. So whenever satellites are closest to the Earth, I'm going to use the term perigee for that. And whenever satellites are farthest from the Earth, I'm going to use the word apogee for that. So for example, the same thing in case of, let's say this is Earth, and I have a satellite moving in elliptical orbit, then this point here, I'm going to call it apogee. And this point I will be calling it perigee. So I will be using these two words a lot in this particular module. That was Kepler's first law. He also gave his second law. Second law was planets sweep equal area in equal time. Not important. Third law, he talked about the revolution period, that how revolution period matches with the ellipse का जो axis है, major axis है. I will not go into that part. उसमें हमको डिटेल में जाने की जरूरत नहीं है. You just have to remember the first law, that planets revolve around sun in elliptical orbit. Now here is the thing, Kepler gave a mathematical law. He gave 3 mathematical laws, but he did not have an explanation for those mathematical laws, that why is it happening, why planets are revolving around sun in elliptical orbit. And that was actually explained by Newton, one of the greatest, perhaps the greatest mind who has ever lived, was Sir Isaac Newton. Sir Isaac Newton is known for so many things. He did so many things by the time he turned 30 or even 27 years old. He developed laws of motion, he talked about universal gravitation, he developed an entirely new branch of mathematics called calculus. He knew about viscosity in liquid, so he did so many things in fact, the first quarter or hardly 30 years of his life. So Sir Isaac Newton, he is known for lot of things. I only want to explain 2 things here. That how Newton explained why planets are revolving around sun. I can again explain apogee and perigee. Point बस ये है that मान लो ये अर्थ है, this is Earth, and a satellite is revolving around Earth. Then there will be a point where satellite will be the farthest from Earth. ये जो distance है, and there will be a point where satellite will be closest to the Earth. So that farthest point is called apogee, and the closest point is called perigee. We use the same word in case of moon also. So moon is revolving around Earth in elliptical orbit. It's near circular, but little bit elliptical orbit. So whenever moon is closest to the Earth, we will say that moon is at its perigee. And whenever moon is at the farthest point from Earth, we will call it at apogee. So Newton is known for a lot of things. I only want to highlight 2 things. I want to talk about his laws of motion, and I want to talk about his idea of universal gravitation, that law of universal gravitation. Newton gave 3 laws of motion. Newton was very much interested in asking this question, that why things move and why do they stop. And he gave 3 laws of motion. The first law, which is simply called law of inertia, which says that if the net force is 0, that if an object is not experiencing any external force, then it will remain unaccelerated. It is not going to accelerate, right? Simple. In one line, if I have to say, if net force is 0, system remains unaccelerated. That is what Newton said in first law. It may seem like a very simple fact, but it's much more nuanced. There are a lot of nuances which people do not appreciate about Newton's first law of motion. One thing which all of us appreciate is जैसे इसको हम ऐसे स्कूल में ऐसे हमने पढ़ा होगा that if an object is at rest, it will keep at rest. If an object is in motion, it remains in motion. Now here is the thing, the first thing which people do not appreciate is that there is nothing called perfect rest or perfect motion. There is nothing called absolute rest or absolute motion. Rest and motion are simply relative. It depends upon in which frame of reference you are, right? So for example, right now all of us are with respect to each other because our position is not changing with respect to each other. However, somebody who goes outside Earth will see that Earth is rotating, Earth is revolving, and for that person, because we are part of Earth as a system, then we are also moving along with Earth. So we are in motion. So it should be very clear that when Newton is saying that objects remain at rest or at motion, he is specifically talking about in a frame of reference. So if in a frame of reference, objects are at rest, then they will keep at rest unless there is a force in that frame of reference, right? If they are already in motion, then they will remain in that motion in constant velocity in a straight line unless there is an external force applied on it. The first part is very simple. First part is appreciating first part that this pen is at rest. I throw it, it gains a speed, it comes in motion because of the fact that I applied a force upon it. But people do not appreciate the other two parts of the first law. That if something is already in motion, then that object will keep in motion, it will remain in motion, and motion on a straight line unless there is something which is opposing that motion. And इसको भी imagine करना बहुत simple है. Imagine you slipping on a ice floor. That ये तो floor है, यहाँ पे बहुत सारा friction है. But अब imagine करो कि कोई object है, ice floor पे slip कर रहा है. I'm assuming that जो ice floor है, वहाँ पे friction करीब करीब zero है. In fact, in my thought experiment, I'm assuming friction to be completely zero. Now imagine that this is a very large ice floor. There are no completely uniform floor. कहीं पे कोई ऐसे उबड़ खाबड़ कुछ भी नहीं है. It's a very flat floor. And you throw something, you give something a speed. Now imagine this object. Will it come to at rest all by itself if the floor is frictionless? The answer is no. It will not come to at rest unless there is an external force upon it. So that is also a very important part, that if an object is already in motion, then it will remain in motion. So acceleration is also reduction of velocity. That even if your velocity is reducing, we use in English, we call it deceleration. But deceleration is also nothing but a type of acceleration. So even when you increase your velocity or decrease your velocity, for both of that you need a force. So you cannot decrease your velocity all by yourself. And you cannot increase your velocity all by yourself. That is what Newton's first law is saying us. But it is also saying one more thing, that you cannot change the direction all by yourself. Again, imagine the same thought experiment, that I threw something on ice floor, moving in a straight line. Can you imagine that going in a straight line, suddenly it moved all by itself without any force? You cannot. So even if I have to maintain the same speed, but I have to change just the direction, that I had an object going in a straight line, and that object had to change its direction. Even for that change in direction, I need a force. This cannot happen without force. So Newton's first law of motion is actually introducing us to four things. It is telling us there is no absolute rest and motion. Rest and motion are completely relative to each other. Second thing, it is telling us that if you are at rest in a frame of reference, you cannot start your motion all by yourself. You need some external force. Third thing which it is telling us, that if you are already in motion, you cannot come to a stop unless there is an external force. And the fourth thing which it is telling us, that if you are already in motion, you also cannot change your direction unless there is some external force. So Newton's first law of motion is telling us a lot of things. And it's a very, very important law. One of the most fundamental law about how objects, why objects move or why they come to rest. By the way, just to further talk about this entire idea, that how this entire concept of rest and motion is relative, that in the same example which I talked about, that think about a person who goes away from Earth, and for that person, all of us are in motion because Earth is rotating, Earth is revolving. Now, in this particular picture which I showed you, I'm assuming sun as a reference point, and in sun as a reference point, I have assumed sun to be stationary, sun to be fixed, and planets to be revolving around sun. But think about it. I do know that even sun is not stationary. If I go outside solar system, then I'm going to find that sun is revolving around the center of Milky Way galaxy. At the center of Milky Way galaxy, there is a very heavy, supermassive black hole. We call it Sagittarius A. I will be talking about that in later classes. And the same way planets revolve around sun, all the stars in galaxy, all the hundreds and billions of stars of a galaxy, they revolve around the center of the galaxy because of presence of that supermassive black hole. So now imagine somebody or some frame of some observer goes outside solar system, and that observer will not look at a stationary sun. Right? That observer will perhaps see something like this, that you have sun revolving around the center of Milky Way galaxy, and planets are spiraling around it. So they're not moving into now some elliptical orbit, they're now moving into some sort of spiral motion as sun revolves around center of Milky Way galaxy. And somebody who goes outside Milky Way galaxy will find that how Milky Way galaxy and other galaxies are going away from each other, universe is expanding. So nothing is at rest. There is no notion of absolute rest and absolute motion. It totally and totally depends upon what is your frame of reference. Your frame of reference decides that something is at rest or something is in motion. And that is what Newton's first law of motion introduces us, the concept of frame of reference, that how powerful that idea is. However, since all of us are part of solar system, we do not have to worry about the second model. We simply have to, even this model is more than enough for all of our calculations. None of our calculations will be wrong if I assume this particular model, simply because we are part of solar system. Just in case if we do, let's say for example, go outside solar system, then this model will not be enough. We will have to look at the other model. You had a question. Venus का revolution? वेस्ट टू ईस्ट रोटेशन है, ये तो रिवॉल्यूशन दिखा रहा है. रोटेशन किसका दिख रहा है आपको इसमें? कहीं पे भी रोटेशन तो मैं दिख ही नहीं रहा यहाँ पे. Venus rotates west to east. ठीक है? Venus rotates west to east. Rotation and revolution are two different things. Anyways, first law. Second law of motion, what Newton said in second law of motion. In second law of motion, Newton gives us how to measure force. That if objects are accelerating, then based on that acceleration, can we calculate force? That what will be the magnitude? In first law, Newton is telling us the nature of force. What is the nature of force? It causes change in motion. What type of change? Either increasing velocity, decreasing velocity, or even changing the direction of velocity. Either of these three things, I need a force. So in first law, Newton is telling us what force does. But second law, it tells us how much it does. What is the quantity of force? Now the actual law is that rate of change in momentum is proportional to force. But the end result of this law is that force is equal to mass times acceleration. However, I should be very clear here that this formula has been derived assuming that mass is constant. There are a lot of things where mass will not be constant. Mass will either increase or decrease. In that case, this formula will not be applicable. But Newton's second law फिर भी applicable होगा. जो Newton का statement है, that rate of change in momentum is proportional to force, that still will be applicable. The only thing is that mathematics will be different. Can you think of systems जिनका mass constant नहीं होगा? Think of some systems जिनका mass constant नहीं है. Yes? No, that is, I'm not talking about that. I will come to that part also. I'm simply saying a system of mass जिसका mass constant नहीं है. It is rapidly changing or gradually changing. All the time it is changing. And we can observe that change. रेडियो एक्टिव मटेरियल तो चलो फिर भी एक बहुत सिंपल रॉकेट सबसे सिंपल, ऑल्दो ये भी बढ़िया एग्जांपल है, पर जो सबसे सिंपल एग्जांपल है वो रॉकेट है. थिंक ऑफ अ रॉकेट दैट एज रॉकेट बर्न्स फ्यूल, all of that fuel it burns, it produces a lot of gases. Those gases come from the back. Rocket gets an upward thrust. So rocket speed is reducing. Think of a balloon, a helium balloon. that helium balloon, even though all of the helium will not come out immediately, but some amount of helium will definitely come out. Or think of a raindrop for that matter. As a raindrop falls on the ground, it accumulates more and more moisture. So its mass is actually increasing. For all such systems, wherever mass is not constant, I cannot apply this particular formula. But nonetheless, Newton's second law, that rate of change in momentum is proportional to force, that still will be applicable. And third law, all of us have studied. Every action has equal and opposite reaction. Now we have, for millennia, we have rowed a boat. But now we know that why rowing boat allows us to move forward. And the same scientific logic is also applicable in case of rocket. That as we row the boat in backward direction, a forward force is generated which allows us to move in forward direction. But the same logic is also applicable in a very sophisticated technology, the so-called rocket technology. That rocket ka jo fuel hai, as it burns, the exhaust comes from the back, and as the exhaust comes from the back, an upward force. So lot of gases are coming from the back, and upward thrust is generated because of that. So the more amount of fuel per second a rocket burns, it is going to accelerate even more and more. जितना ज़्यादा fuel burn होगा, जितना ज़्यादा gases का speed होगा यहाँ पे downward direction में, उतना ज़्यादा एक upward force होगा which will lift rocket from earth. So even in case of rocket, that idea that every action has equal and opposite reaction is applicable. The same idea which is also applicable why a boat moves forward in a river, in a lake, or in an ocean for that matter. Okay, this is the first thing, that laws of motion. The second thing, which I already have in fact talked a little bit about, but let me introduce that in more detail, the concept of vector and scalar. We cannot go into this entire discussion of space technology without appreciating the difference between vector and scalar. So vector jo hai, there are certain quantities in physics that if you have to describe them, you have to talk about both of their magnitude and direction together. If you only give their magnitude, it will not be complete information. So to provide complete information, you need to also talk about their direction. Jaise, I can start with a very simple example. I'm standing here, I am making a statement that I'm going to move by 1 meter. Is that complete information? It's not at all, because I haven't told you in which direction I'm going to move. If I only tell you 1 meter, then you can draw a circle of 1 meter around me and I can be anywhere at that particular point. So whenever I'm providing information where magnitude is not enough, along with magnitude I also need to talk about direction, then those quantities I'm going to call it vector. Force. Let's say I'm making a statement that I'm going to apply this force of 1 Newton. Force का जो SI unit है, वो Newton है. So I'm going to say that I'm going to apply force of 1 Newton on this particular pen. And I ask you to tell me that in which direction it is going to fall. Of course you cannot, because I haven't told you 1 Newton in which direction. So whenever I need both magnitude and direction to describe a particular physical parameter, then I will call those parameters as vector. So simple, parameters which require both magnitude and direction, but parameters which are magnitude is more than enough, direction का कोई meaning नहीं है, we call those parameters as scalar. जैसे this pen weighs, let's say, 100 gram. 100 gram towards north, towards south does not make any sense. 100 gram is 100 gram. यहाँ पे direction का कोई मतलब नहीं है. So whenever I do not need to describe direction for something. I will use all of those parameters, all of those physical quantities as scalar. Whenever I need a parameter, whenever I need both direction and magnitude, I will call those parameters as vector. So let me give you a few examples here. If I have 2 points here in space, that particular straight line which is joining these 2 points, it has some magnitude, but it also has a very fixed direction. That it has a very specific direction. So this vector here is called displacement. And यही rate of change in displacement, कि per unit time में displacement कैसे change हो रहा है, we call that rate as velocity. And that mass times velocity is called momentum. That rate of change in velocity is called acceleration. That mass times acceleration becomes force. So all of these are vector quantities. That for all of them, if I only tell you the magnitude part, will not be enough. I also have to specify in which direction these quantities are operating. These particular parameters are operating. Just magnitude is not complete information. But यही displacement का अगर हम खाली magnitude बात करें, I do not tell you the direction, but only give you the magnitude. That is called distance. Similarly, if I only give you the magnitude of velocity, जैसे कार का जो आपको मीटर बताता है, बाइक का जो मीटर बताता है, जो बाइक का मीटर है, that only tells you speed. It does not tell you the direction. So if something is only giving you the magnitude part, we call that speed. We do not have something similar for acceleration, but there are many other parameters, things like mass or energy or work or power, all of these things. All of these things are example of scalar quantities. We do not have to describe their direction, we simply have to talk about their magnitude. That will be more than enough. Now the reason I have talked about the concept of vector and scalar here is that for acceleration to occur, acceleration is rate of change in velocity. But velocity can change in multiple ways. Velocity can increase, velocity can decrease, and velocity का जो direction है, that can also change. So if any of those 3 changes are happening, that velocity is increasing, decreasing, or direction is changing, for either of these 3 changes, acceleration is happening, and Newton's first law is telling us that acceleration is not possible without force. So even if just direction is changing, even then it requires a force. जैसे I am going in this particular direction with speed of 50 meter per second. I changed my direction to 50 meter per second. I was going eastward, moved southward, 50 meter per second. And I have a question that have I accelerated somewhere? The answer is yes, I have at this point. So my acceleration from this to this point is 0, from this to this point is 0, but my acceleration at this point is not 0, simply because I have changed my direction. एंड इसको एक्सपेरिमेंट करना बहुत सिंपल है. आप एक रोड पे चले जाओ, बहुत ही स्मूथ रोड हो, जो मान लो 100 किलोमीटर का रोड है आपका. टेक योर बाइक, लेट्स अज्यूम दैट योर बाइक हैज एवरेज ऑफ 50 किलोमीटर पर लीटर. स्मूथ रोड है, आई एम एज्यूमिंग दैट बहुत ही स्मूथ रोड है, कहीं पे कोई जर्क नहीं है. इंडिया में मुश्किल है थोड़ा मिलना, बट यू गेट द आइडिया. एंड यू आर मूविंग विथ कॉन्स्टेंट स्पीड ऑफ लेट्स से 50 किलोमीटर पर आवर, and you are going to consume 2 liters of petrol. Do the same experiment on a circular track. That use a circular track of 100 kilometer, जो circumference है 100 kilometer का है, and you maintain the same speed, exactly same speed, and then check that how much petrol you have consumed. So in the second case, because you require constant acceleration, there will be more force on your engine, and it is going to consume more and more petrol. So there will be relatively more petrol consumption in the second case compared to the first case, where the force on the engine was not that much. The engine, of course, has to work against friction part, and because of that, it has to consume fuel. That is there, but nonetheless, in the second case, your fuel consumption will be a little bit more. The point I'm trying to make here is that even if you are maintaining exact constant speed, but all the time your direction is changing. That is what happens in case of circular motion or elliptical motion. Think about it. If something is moving in a circle, then all the time its direction is changing. Newton's law is telling us that objects tend to move in a straight line with constant velocity. Now clearly this is not a straight line. All the time objects are changing their direction. So what Newton's law is telling us, that for that to happen, I need a force. Without a force, this circular motion, or for that matter, an elliptical motion, is not going to be possible. So let me now introduce the third concept here, which is called centripetal force. Whenever objects are moving into some sort of closed path, which can be, let's say, a circle or elliptical motion, then as per Newton's first law, the object all the time should move in some straight line, but all the time their direction is changing. So even if they're maintaining a constant speed, they still need a force towards center, because that force towards center is not allowing them, some sort of attractive force, which is not allowing them to escape. But this object has enough energy that it is not going to come at the object itself. It is able to maintain a constant circular motion. So such type of force towards center is called centripetal force. I will repeat, centripetal force will be there even if speed is exactly constant. Even if you maintain the same speed, let's call that v, and let's say this radius here is r of this particular circle, then even in that case, you need a force all the time. Even though your speed is not changing, but nonetheless your velocity is changing, and acceleration is not rate of change in speed. Acceleration is rate of change in velocity. So such type of force, where to maintain a circular motion, I need a force towards center. Such type of force is called centripetal force. For different things, the source of centripetal force can be different. I take, for example, I have a let's say small thread, and मैंने एक ball लगा रखा है और मैं घुमा रहा हूँ. So जो thread का जो tension है, that is providing the necessary centripetal force. Or I have taken a bicycle moving in a circular motion on a flat road. वहाँ पे circular, I need a force towards the center. What is the source of that force? Imagine मेरा problem क्या है? That एक मान लो यही room है, ये बड़ा flat सा surface है. Let's say that there is no chair. Somebody is moving with a bicycle in a circular motion. I am saying that for that circular motion to happen, it will not be possible unless there is a force towards the center. Without that force, this circular motion will not be possible. I want you to tell me that if I am moving on this particular, in this room with a bicycle, what is the source of that force? I need an external force. What is that external force here? We cannot apply same force on the same system. Friction, it's as simple as that. It's friction. Whenever you are moving in a circle, you have a sliding tendency outward. आप जब भी घूमते हो सर्कल में क्या होगा? थोड़ा सा बाइसिकल आपका बेंड होगा. There is a sliding tendency कि आप सेंटर की तरफ गिर जाओगे. And friction always operates opposite to the sliding tendency. So there is a sliding tendency outward, and because of that there will be an inward frictional force. So friction will allow for that circular motion to occur. Again, same thing, go on an ice track, assume that it is frictionless, you cannot move in a circle. All the time you will be keep falling down. Simply because there is not enough friction which can stabilize that particular circular motion. So I need a source of force for circular motion, for elliptical motion to occur. And that leads me to come to the fourth concept which I wanted to discuss before I jump to the types of orbit discussion, is the concept of gravitation. Newton had this very important question in his mind, that why that apple fell on the ground or on his head apparently. Why did it not fly in the sky? It may seem like a random question. देखो यही होता है कि science, I told you in the starting of the class, science starts with some very basic question. Things which you have seen so much in your day-to-day life, that you take that for granted, that this is how things are supposed to happen. Right? जैसे मान लो कि अभी हम सब आजकल स्मार्टफोन इतना यूज करते हैं that we do not even know the science behind the working of the smartphone. कि इसका जो ये पूरा स्क्रीन है वो स्क्रैच क्यों नहीं हो रहा है और इतना फास्ट क्यों है, जो भी है. We do not, simply because we use it so much. So apple falling on the ground, we take that as a universal fact and we do not even think about it, that why that apple is falling on the ground. But Newton thought about it, that why that apple is falling on the ground, why is it not flying in the sky? And that is where he came to this conclusion that objects with mass, they have this attractive force towards each other. So if there are two objects, m1 and m2, separated by a distance r, then Newton is telling us that there is an attractive force between these two objects, and Newton was able to quantify it. The beauty of Newton's law is that he just did not give the theory, he also quantified it, that this force of attraction will be proportional to the mass and inversely proportional to the square of the distance. जितना ज़्यादा mass होगा, force इतना ज़्यादा होगा, जितना कम distance होगा, force उतना और ज़्यादा होगा, square से ज़्यादा होगा. And because it is proportional, I need some sort of proportionality constant. That proportionality constant here is called G, capital G. And capital G, does anyone remember the value? 6 point? 10 to the power, that is more important. Minus 11. ये ज़्यादा important है. Forget about that 6.6. 10 to the power minus 11, for me that is more important. Which basically is telling us that it is a very, very small force. जो 10 to the power minus 11 quantity है, वो बहुत कम है. So unless either or both of that mass, m1 and m2, is very high, that force will be negligible. जैसे for example, all of us have mass here, but we are not attracting each other because of gravity, simply because the attractive force among us is almost zero. That will be in the range of 10 to the power minus 9, 10 to the power minus 10, which is nothing but zero. We can simply assume that to be zero and that will be fine. But if one of the object becomes very massive, for example Earth with trillions of kg of mass, or both of the objects become very massive, such as Earth or Sun, trillions and trillions to trillions of mass, then this gravitational force cannot be neglected. This gravitational force will very much be visible, its impact will be very much felt, and that is what Newton told us in his entire idea of gravitational law, that objects with mass, they attract each other, right? Now Newton used all of that idea together. His laws of motion, the concept of vector and scalar, the concept of centripetal force, and the concept of gravity. And he came to this conclusion that why planets are now moving around sun in elliptical orbit. He was also able to prove mathematically that why that orbit is elliptical, why it is not circular. He was able to explain that if the gravitational force का जो nature है, ये 1 by r square से vary करेगा. So why that general case of orbit will be elliptical? With this new branch of mathematics he himself had developed called calculus. So Newton applied all of that idea together and he was able to explain these profound events which human beings have always wondered about, that where are the stars coming from, what happens, what are these planets, and how are they moving. And Newton was able to explain all of that, almost all of that, right? And that is one of the most important milestone in the field of astronomy. But Newton also did a thought experiment. In this thought experiment, Newton imagined, thought experiment का मतलब होता है something you imagine in your mind. And you imagine that experiment using your scientific ideas. So Newton imagined a thought experiment that, let's say, from Earth, I take a ball, spherical ball, and I throw that ball with some speed in some direction. I do know, I hope you have studied about projectile motion, but we do know that what is going to happen, that ball is simply going to move like this and it is going to fall on the ground somewhere, right? Newton imagined, what if I give it more speed? It is going to drop further. It is going to drop further. So Newton imagined in his mind that if I keep increasing the speed of this ball in my hand, then it is going to fall further and further. So Now Newton imagined a situation where it is able to cross thousands of kilometers. Simple, if I am only throwing this ball from my hand, then it is going to cross few meters. But Newton imagined that in future, let's say human beings do develop a technology where I can throw something with very, very high speed of kilometers per second. Is tarike ka speed, we are talking about that. And he then imagined that if I keep throwing this, it is going to fall farther and farther. But what if it comes back in the space itself? What if it does not fall down? What if the object has enough speed that it does not fall down, and wherever it reaches to the sky at its maximum point, it comes back to the same point after a revolution? What is going to happen after that? And then Newton concluded that if there is no external force on this object, if nothing is going to oppose its motion, if nothing is going to reduce its kinetic energy, reduce its speed, then it will keep maintaining the same motion. Because if it maintained one orbit and there is nothing which is opposing its motion, nothing which is reducing its speed, then it will keep maintaining the same orbit all the time. That is what Newton's conclusion was. And Newton thought all of that in 18th century. We launched the first satellite in mid of 20th century, in about 1950s. And turned out that Newton ka jo pura assumption tha, that all of that was correct. That if I launch something with very high speed with the help of a rocket, a satellite perhaps, then that satellite, if it ejected around Earth at some height, let's say that height is 300 kilometer. Now at 300 kilometer, air becomes so thin that jo air drag force hai, hum easily usko neglect karenge. Now same thing happening, let's say at 20 kilometer. Let's say I have thrown something at 20 kilometer with so much of speed that it is able to achieve an orbit. But it will not be a stable orbit, because at 20 kilometer atmospheric drag will be very strong. जितना ज़्यादा स्पीड होगा उतना ज़्यादा एयर ड्रैग होगा, और एयर ड्रैग के कारण स्पीड क्या होगा, कम होते चले जाएगा. There is something which is opposing my motion, so my speed will keep reducing. I will keep spiraling towards Earth and I am going to fall down towards Earth. But if I am flying, or if I am revolving at height of, let's say, 400 kilometer, 500 kilometer, where the atmosphere is almost negligible, but nonetheless I am still in that Earth gravitational field, then if I have enough speed that I can maintain a stable orbit, and since I can maintain a stable orbit, there is nothing which is opposing my kinetic energy, my speed will be more or less same. So if I was able to maintain one orbit, I will be able to maintain thousands and lakhs of orbit in subsequent year, for as long as if the materials do not degrade, then it can keep revolving for that matter millennia. That is what Newton's conclusion was. And that is Newton thought what must have occurred in case of planets also. That solar system must have been formed Newton had no idea how much long ago, but he clearly came to this realization that planets and suns, all of those things must have been formed. As those planets came closer to sun, they attained more and more kinetic energy because of that gravitational pull. But at a point of time, they had enough kinetic energy that rather than falling in the sun, they kept revolving around sun. Now nothing is opposing Earth's motion. There is no mechanism in this entire solar system which is literally trying to stop Earth. So since nothing is stopping Earth, Earth will keep revolving simply because it was able to attain one revolution. And all of that, now we know all of that happened about 4.5 billion years ago. Sun is about 4.7 billion year old star. Earth is about 4.5 billion year old planet. So we do know, we have a rough idea, if not exact idea, that how solar system must have been made, or how Earth and other planets must have been made. That is another thing about science, that nobody has actually gone back in time 4.5 billion years ago to look at the formation of solar system, but we can nonetheless develop a rough idea, a good idea, that how things must have occurred. So now we know that Earth was formed about 4.5 billion years ago, maybe as a gaseous giant. It cooled down. As it cooled down, life became possible on the surface of the Earth. As of now, this is the only planet where life is possible, as we know of. Maybe there are other planets where life is possible, but as we know of, Earth is the only planet where life is possible. That's a separate thing. But the point is that irrespective of life on Earth, irrespective of human beings, these objects are there in the universe. And these objects follow laws of physics as propounded by Newton's laws of motion or Newton's idea of gravitation. Later, of course, turned out that Newton's ideas were not that accurate. There were some problems with Newton's ideas, and those problems were rectified by Einstein. So Einstein gave a better theory of gravity. That theory is called general theory of relativity. Maybe we will discuss that in later classes. But Newton का जो gravitational law है, that is more than enough to understand this topic of space technology in our class. So I will repeat what I have said in till now. I have mainly introduced 4 concepts. I started my discussion about laws of motion, 3 laws of motion. I talked about the concept of vector and scalar. I talked about the concept of centripetal force. And last, I talked about the idea of gravity. If you have any question in any of these 4 concepts, now you can ask questions. And you can ask as many questions as you can. It's totally fine. There is a question, what is difference between centripetal and centrifugal force? That's a very obvious question. I think I have given enough of theoretical framework for today's class. So I want you to read about it. It has something to do with called pseudo force. It has something to do with the fact that if you're making an observation in a frame of reference, which in itself is accelerating. I want you to read more about it. I will answer this question in next class. Ask this question, that what is the difference between centripetal and centrifugal force. Also, I will answer the question, geography ka class to abhi shuru nahi hua hoga. In geography, you will be taught about Coriolis force, something called Coriolis force. I will explain that Coriolis force also, that what is that Coriolis force we talk about. Right, and that has something to do with the frame of reference. If I am making an observation where frame of reference in itself is accelerating, then I have to apply something called pseudo force. And that is what centrifugal force is. But detailed explanation I will give in next class. I think for today's class, enough of theoretical framework. If you have any question in any of the theoretical framework till now, you can ask questions. Yes. You have to be louder. Okay, that's a very valid question. So let me introduce the concept of escape velocity. And the answer is of course yes. That अभी तक हमने जो मेरा thought experiment था, और Newton का जो thought experiment था, Newton assumed that the object has enough energy that it does not come on the ground, but does not have enough that it escapes from the Earth gravitational pull. So Newton also asked the same question, that will there be a speed that if I throw something with this speed, that object forget about coming on the Earth, forget about orbit, it is going to escape from Earth's gravitational pull. And that speed is called escape velocity. It's not a very difficult calculation. It can be very easily shown that no matter how heavy your object is, doesn't matter. Mass पे बिल्कुल dependent नहीं है. If you throw something with 11.2 km per second, then this object will not come back to Earth. It will move like this. Of course, its motion will be curved because of Earth's gravity, but it is not going to make an orbit around Earth. It is going to escape from the Earth. And 11.2 से जितना ज़्यादा होगा, वो escape उतना clearly दिखेगा. और ज़्यादा होगा, clearly दिखेगा. So जितना ज़्यादा speed से आप throw करोगे, above 11.2 km per second, that object is going to escape from the entire Earth gravitational pull as fast as possible. But you do need minimum of 11.2 km per second from Earth, no matter how heavy an object is. Yes. Revolving. The word is revolving. Okay, yeah, perfect. So that's a very valid question. Mm-hmm. Sorry, can you repeat your question? Yeah, sun, yeah. Milky Way, yeah. Okay. Yeah, yeah, yeah. Okay, now that's okay. Both of these are fantastic question. The very first question you had, sorry, I forgot your first question. The second question was so, it took so much of time. Why don't it fall down? Okay, so that question, that answer is very simple. So the question was that what is gravity doing if it is not allowing object to fall down? The answer is very simple. It is providing the necessary centripetal force that it can find a stable orbit. And इसको experiment हम कर सकते हैं. You take a, आप मान लो कि एक आपके पास एक कंटेनर है, कोई कंटेनर है, टेक अ वेरी फैब्रिक, कोई भी फैब्रिक लो, उसको टाइटली tie it around that container, keep something heavy in the center and throw some smaller object around it. Now you know that it is going to spiral down and it is going to fall down. Now it is falling down because there is a friction between that fabric and that spherical ball. If you could have attained a fabric which was frictionless and you allowed that smaller spherical ball to attain a stable orbit, then believe me, that would never have fallen down. So the point here is why it does not fall down. Why does Earth not fall down inside Sun? Why does Moon not fall on the Earth? Or why not satellites fall on the Earth? Again, Newton has answer to that question. That it is because at a particular speed, at a particular distance or group of distance, you have enough energy that you do not fall down. What was my thought experiment? I keep increasing the speed, I fall down. But what if my speed is so much that I do not fall down? I find a stable orbit. So in that particular case, what is gravity doing? Gravity is allowing that necessary centripetal force between this object and Earth. If I'm assuming a satellite, or if I'm assuming Earth and Sun, then gravity is allowing Earth to attain enough centripetal force that it can find a stable orbit. Now Earth does not have enough energy that it can escape from solar system. Earth also does not have so less energy that it would have kept falling inside Sun. It has just enough energy that at a particular point it found a stable orbit. And it is not just true for Earth, it is true for all planets, and it is true for even Earth-bound objects. It is true for Earth-Moon system and satellites around it. So what is gravity doing? Gravity is providing the necessary centripetal force that you can find a stable orbit. The second part of the second question is much more complex. For that, we have to go into Einstein's general theory of relativity. So the second question he was asking is that I just talked about that how Sun is revolving around Milky Way and planets are spiraling. So what is the role of gravity? अब इसको देखो हम कैसे imagine करेंगे? There is another question which I can answer here, that what is the source of gravity? Now that's a very fundamental question and a very complex question. And I will give you two answers here. The first is nobody knows. That gravity at its fundamental level, what it is, it's not very clear. What it does is very clear. What is the best theory of gravity? That theory is called general theory of relativity. In general theory of relativity, Einstein assumes that gravity is because of curvature of space-time. These things will not make sense right now. I will try to explain them in simpler words in later classes, not in today's class, not in this entire topic. That what do I mean by the word space-time curvature? So, but nonetheless, you can ऐसे आप assume कर सकते हो कि जो supermassive black hole है at the center of galaxy, because of that, it is not just Sun. It is the entire solar system which is revolving around the center of galaxy. But within that revolution, you have now imagined that solar system has its own frame of reference, where Sun is so heavy that Earth is revolving around Sun, but the entire system in itself is revolving around a center of Milky Way galaxy. So in that case, it will not just be the Sun, but the entire solar system which is revolving around center of Milky Way galaxy. Any other question if you have? There are few online questions. How planets put in first revolution? They were not put in. For that we have to go into how solar systems or how star systems are formed. And I will be talking about that idea जब हम discuss करेंगे Dr. Subramaniam Chandrasekhar के ideas को. जो हमारा last topic है, contribution of Indians in science and technology. I will be talking about Dr. Subramaniam Chandrasekhar. I will explain nebula, I will explain stellar dust, and how stellar dust allows stars to form and other objects to form. So let me answer this question in later classes, not in today's class. Okay, there is a question, just a second. There is a question that gravitational forces between two masses and centripetal force keep object in circular path. Then how they're different? They're not different. Centripetal force is a concept. What that concept is telling us that to move in a circle, I need a force towards center. To move in a circle, I need a force towards center. Gravity is providing centripetal force in case of motion of planets around sun, or in case of moon around earth, or in case of satellites around earth. But for other objects which are moving in circular motion, that is why I gave the example of imagine a string, you have attached a ball and you are rotating it. आप घुमा रहे हो उसको हाथ में. तो यहाँ पे जो centripetal force है वो tension in the string है. So centripetal force is a concept which allows us to explain that why a particular object will move into a circular motion, or for that matter elliptical motion. So centripetal force common word है, but centripetal force का जो source है, where is it coming from? That will be different depending upon different type of systems we are analyzing. In case of sun and earth system, the source of centripetal force is gravitational force. When we are in lift, why does our body feels light when it comes down? So I will answer that question in the same जब centripetal and centrifugal discuss करेंगे, and I'm also going to talk about गगनयान mission. So why do astronauts feel weightlessness? आपने पढ़ा होगा ना, सबने पढ़ा होगा, देखा भी होगा videos. I'm going to talk about गगनयान mission in subsequent classes, and I will ask this question that why do astronauts feel weightlessness? Why do they not feel their own weight? And the answer to will be actually quite simple, and it will come to the same question that why when lift is going down we feel little bit lighter. Will we not get science and tech notes? I will be giving you handwritten notes. You'll be getting monthly current affairs magazine. That will be the most important notes. If your question is, will we not get value added material? The answer is no. If the projectile is projected perpendicularly from the surface, would it be achieved to a stable orbit to revolve around Earth? Yes, it will be, because 90-degree projectile जो है, हम जब normal, the question he is asking is that if a projectile is thrown at 90 degree with very high speed, will it achieve a stable orbit? Yes, even then it will be able to achieve a stable orbit, because you are thinking that 90 degree गया वापस आ जाएगा. But if you throw it at very high speed, remember Earth is a rotating system. That motion in any case is going to, you will find that it is going to curve. Now why it is going to curve? Simply because Earth is rotating. I will explain that, don't worry. We will discuss that in perhaps today's class itself. Why planets do not revolve around black hole independently? There may be planets who are revolving around black hole independently. As far as we know, maybe around Sagittarius, say you have a lot of objects which fit into that definition of planet, and maybe they are revolving around it. But they are revolving around it black hole independently because they are not part of any stellar system, any star system. If they are part of a star system, then locally they will revolve around their star, and that star itself will revolve around Milky Way galaxy. Is there an object at the center which creates centripetal force? I will not use the word create, but yes, object depends upon what type of system I am analyzing. This in case of Earth-Sun system, yes, there is an object at the center, and the gravitational pull between that object and the other object which is orbiting around it, that is responsible for centripetal force. But for different sources, it will be different. What is the time concept of black hole? Not in this module, not in space technology, but I will be talking about that. Let's take a break here. After that, we will come to the more concrete discussion, types of orbit around satellite. Last question, yes. Why not circular if that is your question? That's a very valid question. You may think that answer is simple, but answer is not that simple, frankly. It has to do with the asymmetry of velocity, and it has to do with nature of gravity. I will simply answer that in two lines. That जो gravitational force का जो nature है, that it is follows that g m1 m2. अब ये तो सब constant होगा, g भी constant है, अर्थ और सन हम ले ले वो भी कांस्टेंट होगा, डिफरेंट क्या होगा? r स्क्वायर. अगर आप इसको सॉल्व, इस फोर्स को एज्यूम करके जब आप सॉल्व करोगे, न्यूटन ने जो डिफरेंशियल इक्वेशन बनाया था, तो जो सोल्यूशन होगा दैट विल कम आउट एज अ जनरल इलिप्टिकल ऑर्बिट. In any case, remember that circle is a very specific case. Ellipse is a general case. And circle is a specific case where the focal points and center, all three of them are coinciding at one point. So that is why general orbits are elliptical orbits. It has also to do with what type of velocity an object is attaining around the heavier object. Answer is not that simple. We have to go into differential calculus to appreciate that why orbits are elliptical and why they are not simply circular. Why not? Some orbits are circular though, that is there. Yeah, it is. Yes, the speed of Earth. So question he's asking is that because Earth is also moving at perihelion and aphelion, that at one point it is very closer to Sun, at another point it is farther away from Sun. Does it have an impact? Of course it has an impact. So when Earth is revolving closer to Sun, its speed is much more. When Earth is revolving away from Sun, its speed is much less. Right? So in fact, Kepler gave, जो Kepler का second law है, that is with respect to this. I told you Kepler gave 3 laws of planetary motion. So Kepler का second law है that roams around this particular thing. That as Earth comes closer to Sun, it is going to attain more speed, and it is farther away from Sun, its speed is going to reduce. Let's take a break here. After that, we will discuss more concrete topic. I will start with orbits of satellites around Earth. There's a question here that if Sun is revolving around black hole, why planet is revolving around Sun and why not black hole? So clearly planet is also revolving around black hole. Should be very clear. If entire solar system is revolving around black hole, then planet is part of it. But within that major revolution around center of Milky Way galaxy, there is another revolution which is going on, is around that local star, right? And within that another solar system level of event, there is another local revolution going on where moon is revolving around Earth, right? So इस तरीके से imagine करो. So entire system is revolving around this supermassive black hole around center of Milky Way. But within that entire system, there are other local revolutions, and all of that is essentially happening because of gravity. You have, I'm very sure that you know about types of satellites. You have some idea about types of satellites and what do they do, right? So for example, we know about communication satellites. The purpose of communication satellite is that it aims to maintain some sort of communication channel between 2 points on Earth, right? So something is happening somewhere. That very good example is satellite television. That if you have at your home Tata Sky, then that Tata Sky is, for example, live IPL अगर आप देख रहे हो, that is a very good example of use of satellite television, use of communication satellite. Or if you listen to some FM radio, very good example of satellite radio. So such type of satellites, we call them communication satellites, one type of satellite. I'll be talking about the satellites in more detail and their applications in next class. In today's class, I only want to introduce about them so that I can have a discussion about orbits of satellites around Earth and why different type of orbits will have different type of utility, different type of benefits. The second type of satellite, which I think many of you may not know about, is group of satellites called Earth observation satellites or remote sensing satellites. So the remote sensing satellites, as the name suggests, they aim to observe Earth observation. They aim to collect data about Earth from far away, right? So from far away, they can look at a very larger part of Earth together. And we are not talking about simple pictures. We are talking about very sophisticated analysis about a lot of physical or chemical or even biological parameters which these satellites are capable of performing. The third type of satellites, which we call GPS satellites, but GPS satellites belong to a group of satellites called navigational satellites. That these satellites, they aim to provide you precise location, that where you are. For example, when you use Google Map or something like that. So these satellites aim to provide you precise location, that what is your latitude or longitude on Earth, where you are exactly on planet Earth. You can also have some dedicated space missions. We can launch telescopes or we can launch space stations. We can launch some experimental observational satellites, small satellites. I am right now mostly interested in These three group of satellites which I have talked about: remote sensing satellites, communication satellites, and Earth navigational satellites. So I can explain why different orbits will have different type of utility. So the first and the most important topic, one of the most important topic from space technology, is to appreciate about types of orbits and why different type of satellites will be launched into different type of orbits. So this is a more concrete discussion about technology. अभी तक जो हमने discuss किया था, we are talking about scientific framework to understand the topic. But this is more of a discussion about space technology. So give this heading: types of orbits around Earth. Types of orbits around Earth. As I was saying earlier, that if you can launch something into space, away from atmosphere, far away from atmosphere, atmosphere starts becoming thin after 100 kilometer a lot. 90% of atmosphere, more than 90% thinning happens above 100 kilometer, and more than 200 kilometer, it is almost absent. Almost, I will not say that it is completely absent, but it is almost absent. So if we can launch something with enough speed that it can find a stable orbit around Earth because of the gravity of Earth, then we can have a stable orbit. We already know that there is a natural satellite Earth has, we call it Moon. Moon revolves around Earth at about 384,000 kilometer. अगर Moon का अगर हम orbit देखें तो average distance जो है, it is an elliptical orbit, but more or less it is very close to circle. What does that mean? जैसे this is also an ellipse and this is also an ellipse. ये भी circle नहीं है, ये भी ellipse ही है, but मून का ऑर्बिट ऐसा दिखेगा, ऐसा नहीं दिखेगा. तो मून का ऑर्बिट इज ऑल्सो एन इलिप्टिकल ऑर्बिट, बट इट इज मच क्लोजर टू सर्कल. एंड जो एवरेज डिस्टेंस है, इफ आई एज्यूम दैट टू बी सर्कुलर ऑर्बिट, देन एवरेज डिस्टेंस ऑफ मून्स ऑर्बिट इज 384,000 kilometer. But I am more interested in launching satellites around Earth, and I want to launch various type of satellites. They perform various type of functions. So what type of orbits are they? And I have many criteria to distinguish among orbits. The very first criteria is based on height. So the first thing, write it down, an orbit is closed path taken by a celestial object or an artificial satellite, taken by celestial object celestial का मतलब naturally occurring objects in the sky, celestial object or an artificial satellite around another celestial object due to gravity लिख सकते हो आप. We launch artificial satellites around Earth. In many types of orbits, which can be divided on many parameters, which can be divided on many criterias, First criteria is based on height. It's a very simple criteria. We have an orbit called LEO, low Earth orbit, which varies from 200 to 2000 kilometer. We have an orbit called medium Earth orbit, which varies from about 2000 to 35,785 kilometer. Then we have orbit called geosynchronous, and high Earth orbits, which is greater than or equal to 35,786 kilometer. One very obvious question you can ask here is that this looks like a very precise value. 200 से 2000 वो round off figure है, ठीक है, वो फिर भी समझ में आ रहा है. But 35,786 is a very precise value. So what is so special about that? I will answer that question hopefully in today's class itself. That has to do with this word geosynchronous. I will explain the meaning of this word. What is this word geosynchronous and what has that to do with this height 35,786 kilometer. So I will come back to this question, don't worry. Right now I want to highlight about another thing. That I have a question here that let's assume I launch a satellite into an orbit of 500 kilometer. Can you tell me if you, or can you take a guess if you do not know, that how much time it will take for this satellite to revolve around Earth? If there is a satellite in 500 kilometer orbit, and 500 kilometer is from the mean sea level. बहुत clear होना चाहिए. We are measuring this height from the surface of the earth. जो mean sea level है earth का, हम उससे height measure कर रहे हैं. So if a satellite is above 500 kilometer from earth's surface, then how much time it will take to revolve around earth for this satellite? Okay, I have 24 hours, less than 24 hours, more than 24 hours. Anyone else would want to take a guess? It will not at all depend upon mass of satellite. Now that is one of the most important thing which you need to remember, that it will not at all depend upon mass of satellite. I did not want to go into mathematics here, but I will use mathematics as a last resort. Right? So in this case, let me explain the mathematics that why it will not depend upon mass. This is Earth. This is a satellite. From center of Earth, let's say this distance is r. I'm assuming this satellite is revolving in a circular orbit for simplicity, for my calculation to be simple. If you have studied physics in class 11th, then you know that if an object is moving in a circular motion with radius r with a speed v, then the required centripetal force is m multiplied by v square by r. So the centripetal acceleration ka value hai, that is v square by r, where v is speed of that particular object, r is that distance of, r is that circle. This is the centripetal force which is required. I also know that where is this centripetal force coming from? What is the source of the centripetal force? That is gravity. So I know that this should be equal to the gravitational pull between this satellite, which has a mass m. Let's call mass of Earth as capital M. Then this gravitational force is capital M, which is mass of Earth, small m divided by r square. Now the first thing which you say is that from m to m, I can easily remove here. So I know that this velocity will be ये आएगा हमारा velocity, right? अब इस velocity में और जो भी speed है, this is speed. इस speed में capital G is gravitational constant, universal constant of gravitation, that is a constant. capital M is mass of Earth, that is also constant. R is the only variable here. So the speed of satellite does not at all depend upon its mass. It only and only depends upon how far it is away from Earth, right? So now my question is, so the first thing first, it does not depend upon speed. Similarly, the same way escape velocity does not depend upon speed. Any object, चाहे मैं globe फेंकूं, चाहे मैं pen फेंकूं, if I can throw that with 11.2 km per second, then it is going to attain escape velocity. It does not matter, or if I have something which weighs 1 quintal, even then it is going to attain escape velocity at 11.2 km per second. The answer is about 100 to 120 minutes. If I have a satellite which I have launched in 500 km orbit, the precise calculation you can easily calculate. आपको speed पता है, आप आराम से distance निकाल लो. Distance will be 2 pi r. यही होगा ना time period. ये distance इसने travel किया, एक circumference of circle. Circumference हम आराम से निकाल लेंगे, that will be 2 pi r. हमने speed अभी निकाल लिया, r हमको पता है. जैसे मान लो r here is 500 km. But in this case, I will have to calculate r from the center of Earth. So Earth का radius is 6400 km, average radius is 6400. For simplicity, let's assume that r to be 600 km. So this r here becomes what? 7000 km. आपको इसको मीटर में कन्वर्ट करना पड़ेगा. We will do all of that calculation in meter. आप फिट कर लो. 2 into 3.14 into r, that is 7000 into 1000 meter divided by v हमने calculate किया है. अब v यहाँ से put करो. I know what is capital G, I know what is capital M, we know the mass of Earth, we know r here also. आपको v मिलेगा. Put that v here, you will get that time into second. Convert that second into days or into hours. You will find that will be about 100 minutes. It will be about 2 hours, not more than 2 hours. So satellite into an orbit of 500 km will revolve around Earth in about 1.5 hours. So fast. So the period of revolution will be very high. Should be very clear that जैसे जैसे height बढ़ते चले जाएगा, speed is going to reduce. Look that r is in denominator. So if r is high, then v is going to reduce. What it means is that as the satellite's height increases, orbit का जो radius है that increases, the speed of revolution is also going to decrease, right? So that time period of revolution is of course going to increase then. So the first thing, that a satellite in let's say 500 or 600 km will revolve in less than 2 hours. 24 hours is a very large, 24 hours is a very large value, 2 hours. How radius is 7000 km? ये r जो हम कैलकुलेट करेंगे मैथमेटिकल कैलकुलेशन में, हम हमेशा सेंटर ऑफ अर्थ से कैलकुलेट करेंगे. अब सेंटर ऑफ अर्थ से क्यों कैलकुलेट करेंगे? फॉर दैट यू नीड टू नो समथिंग कॉल्ड द कॉन्सेप्ट सेंटर ऑफ मास, विच वी डू नॉट हैव टू डू इट हियर. करने की जरूरत नहीं है यहाँ पे. बट ये जो हम r कैलकुलेट करेंगे दैट विल बी फ्रॉम सेंटर ऑफ अर्थ. नाउ वी नो दैट रेडियस ऑफ अर्थ इज 6400 किलोमीटर. एंड इन माई क्वेश्चन आई लॉन्च्ड माई सैटेलाइट एट हाइट ऑफ 600 किलोमीटर. So 6400 plus 600, that is how I calculated that radius to be 7000 km. Anyways, coming back to my discussion. So a satellite in 500-600 km is going to revolve very fast. Compared to a satellite, let's say, which is at the height of 30,000 km. Now that time period revolution will be now close to 24 hours. In fact, जो geosynchronous orbit है, वहाँ पे जो time period of revolution है, satellite का वो exactly 24 hours होगा, 24 घंटे होगा, and that is why that geosynchronous orbit is a very special orbit where the revolution period matches with Earth's rotation on its axis. Anyways, below 35,786 km, all of the satellites will revolve in less than 24 hours. In fact, at 600 km, 1.5 hours. What does that mean? Now, assume that I have a satellite which is revolving at 600 km. Right now, assume this satellite is, let's say, for example, revolving above India or above Delhi for that matter. But because it is revolving so fast, the very next second it is not going to observe Delhi, it will observe some other point on Earth, some other point, you get the idea. So it cannot observe a particular point for very long duration because it is revolving really fast. Compared to that, if a satellite which is far away, let's say at the height of 35,000 km. Now for this satellite, A larger part of Earth is visible simultaneously. हम जितना दूर होंगे हमारा जो line of vision होगा वो area of vision जो होगा उतना ज़्यादा होगा. So this satellite now can observe a larger part of Earth. Plus, because its revolution period is also less, it will be able to observe a part of Earth for longer duration. So you may think that for Earth observation, I told you that a type of satellite which we call Earth observation remote sensing, this may be a good idea, that I get to observe a larger part of Earth simultaneously. But it is not, simply because you are very far away. And if you are very far away, your resolution decreases. The same way your eyes cannot see very far away, right? Or your ears cannot listen to something which is a sound source which is very far away. Even satellites, with all of the sophisticated equipments they have, they cannot calculate data, good quality data from very far away. So जितना हम पास में होंगे, जो हमारा डेटा क्वालिटी होगा वो उतना बेटर होगा. ये बहुत ऑब्वियस है, बहुत सिंपल है इसको समझना. दैट अगर हम पास से, जैसे मान लो हमको दिल्ली का ट्री कवर देखना है, वी हैव टू मेजर दैट हाउ मच ट्री कवर देयर इज इन दिल्ली. बाय द वे वी कैन डू दैट with the help of satellites. We can measure the tree cover of Delhi or forest cover of Delhi. So ideally I should be closer to Delhi. I should be not very far away. My data quality will be reduced. That data will not be very reliable. But if I am collecting the same data from closer to Delhi, then my data quality will be better. So the point I am trying to make here is that जो lower orbits हैं, जो low earth orbit जो अभी मैंने discuss किया, these low earth orbits are very much suitable for remote sensing satellite, for earth observation satellite. Low earth orbit के बहुत सारे benefits होंगे. यहाँ पे रॉकेट से लॉन्च करना आसान होगा. आपको जितना हाइट पे भेजना है, launching that will be more and more complex. Such type of launches will be difficult, expensive also. जितना कम हाइट पे भेजना है, it will be simpler. So low earth orbit का जो सबसे पहला benefit तो यही है, that launching satellites into such orbits will be simpler. It will be more cost effective. The second benefit here is that satellites here will be able to observe a particular part of Earth and will be able to collect data of very high quality in very high resolution. So that is the benefit of low Earth orbits. The shortcoming here is that it will not be able to monitor same part of Earth continuously. In fact, it will only be able to monitor a particular part of Earth for a minute or two. After that, it is going to monitor some other part of Earth. After that, some other part of Earth. You get the idea. But the same thing is also not good for communication. Because remember, what is communication? Communication essentially is that I'm trying to create a communication channel between 2 points on Earth, which is very far away. So I have a station, मान लो there is a radio station, this is Earth. I have a radio station which is sending some signal here. That signal is being received by this satellite. Satellite amplifies that signal and sends it back to Earth. But for that signal, for the satellite to receive this signal, it has to be line of sight. What does that mean? मान लो I have a Earth station which is, let's say, situated in Delhi. There is a radio station which is in Delhi. And ISRO का एक satellite है जो अभी यहाँ पे है. I will not be able to maintain a communication channel with a satellite which is at this part of the Earth. In fact, this part of the Earth or this part of the Earth. I will only be able to maintain a communication channel with a satellite which is perhaps in this part of the sky. तो हम जितना ज़्यादा ऊपर होंगे, right, उतना ज़्यादा probability होगा that I will be able to receive this signal from Delhi. If I'm very closer to Delhi, if I'm here, then maybe for a very brief period, yes, I will be able to receive signal from Delhi. But the very next period, that line of communication will be lost and I will not be able to receive a signal. So for communication satellites, ideally I should go higher and higher. Because हम जितना ऊपर जाएंगे, I will have more and more area visible to me, and any radio satellite which is in this entire area, I will be able to receive signal if I am, let's say, at height of few hundred, not few hundred, few 10 of 1,000 kilometer, 20, 30, 35,000 kilometer. So for communication satellites, ideally I should go at higher altitude. For remote sensing satellite, I should remain closer to Earth, right? Reason is very simple. If I'm closer to Earth, my data quality will be really good in case of remote sensing satellite, but my communication will suffer. In case of communication, I do not have to collect data about Earth's surface. What I have to do is that I have to maintain a communication channel. And then in that case, जितना large part of Earth एक साथ visible है, उतना ज़्यादा better होगा कम्युनिकेशन होने का पॉसिबिलिटी जो है उतना ज़्यादा बेटर हो जाएगा. सो दिस इज व्हाट आई एम ट्राइंग टू, इफ आई हैव टू शो दैट with a simple picture, that imagine a satellite in low Earth orbit, it can only observe this part of Earth and also communicate with this part of Earth. But a satellite here will be able to observe a larger part of Earth and will also be able to maintain communication with this entire part of Earth. However, since it is very far away, the data quality will be compromised. So it is not all the time, sometimes it will be used for Earth observation also. But most of the time for Earth observation, I will go into low orbits. For communication satellites, I will go into high orbits. Is this clear? Is this concept clear? Yes? For that, we'll need to now launch more satellites. That answer is very simple. The question is asking is that what about communication with other end of hemisphere? So for that, we need to create a constellation of satellites. And that is why कोई भी communication system खाली एक satellite का नहीं होगा. However, if I am launching a satellite into low Earth orbit, then I need to create hundreds of satellites, a constellation of hundreds and perhaps thousands of satellites to cover the entire Earth. But if I am into higher orbit, then maybe few of them, 4, 5, they will be more than enough to cover the entire Earth. So that is how we establish communication. Any other question if you have? तो आप लिख सकते हो in fact. Write down here. Low Earth orbits are, or LEOs are simpler to achieve, and useful for remote sensing satellites, sensing satellite. High orbits are difficult to achieve, relatively difficult to achieve, and more useful for communication satellites. ये हम आगे भी डिस्कस करेंगे, बट ये थंब रूल बिल्कुल भी नहीं है. वी हैव रिमोट सेंसिंग सैटेलाइट्स इन हाई ऑर्बिट्स and we have communication satellites in low orbit. It's not a thumb rule. I'm just simply saying that these are the benefits. The second criteria is based on inclination. So I was talking about criteria. Second criteria here is based on inclination. Here also I can have three types of orbits. I can have equatorial orbits, inclination. I will define inclination, don't worry. But inclination will be approximately 0 degree, that is approximate sign. Polar orbits will be approximately 90 degree. And inclined orbits all the rest which are not around 0, not around 90, will be inclined orbits. First let me explain what do I mean by the word inclination here. Inclination का मतलब ये है that I'm measuring angle between two planes now. So plane के बीच में angle measure करने का तरीका सबसे पहले तो clear होना चाहिए. जैसे imagine this is one plane and imagine this is another plane. So this angle here is 90 degree. I need some other object. Can I take your notebook just for a second? I will give it back. So imagine this is a plane and this is a plane. So this here angle between these two planes is 90 degree. This here will be less than 90 degree and this will be more than 90 degree. Simple. That is what we are trying to do. So now imagine equatorial plane, that this is globe, this is equator. ये जो mid point आप line देख रहे हो, we call this equator. हम इसी equator को extend करते हैं space में. So for example, this laptop here represents the equatorial plane. And I take any other point here. So उसके around जो भी अगर मान लो हम satellite अगर हमारा inclined orbit हो, तो इन दोनों plane के बीच का जो angle होगा, that will be the inclination of that particular satellite. So for example, look at this particular stand here. This will be an example of polar orbit because ये हमारा equator है और ये pole के around है. So this will be a polar orbit. So anything from 0 to 90 degree, let me make a diagram. This is Earth. This line here is equator. So if I have a satellite just above equator, I will call it equatorial orbit. This is North Pole, Arctic. This is South Pole, Antarctic. If I have a satellite which is revolving around from North Pole to South Pole, but above North Pole and above South Pole, then that will be polar orbit. And rest all of the orbits. So for example, if I have to know the inclination, तो ये जो inclination equator का I am assigning the value of 0 degree. कि इक्वेटर से जो मेरा रेफरेंस पॉइंट है वो इक्वेटर है और जो इक्वेटोरियल प्लेन है उसका इंक्लिनेशन इज 0 डिग्री एंड आई एम मेजरिंग इंक्लिनेशन फ्रॉम इक्वेटर. सो फॉर एग्जांपल इन दिस पर्टिकुलर केस दैट इंक्लिनेशन विल बी 90 degree. And I can also have, for example, this is equatorial orbit and this here is an inclined orbit. So in that case I am measuring this inclination and this will be less than 90 degree. And third scenario can be that this is equator and this is my orbit. So in that case my inclination will be more than 90 degree. And if it goes to 180 degree, 180 degree will be same as 0 degree. Should be very clear कि जो 180 degree है that will become same as 0 degree. So जो inclination of orbit है that can vary from 0 to 180 degree. If you want to make all of that diagram together, this is an equatorial orbit. This is a polar orbit. This here is an inclined orbit जिसका inclination will be acute angle, some acute angle. And this here will be an orbit whose inclination will be some obtuse angle. So inclination can vary from 0 degree to 180 degree. If it is around 0 degree, just a second, if it is around 0 degree, does not have to be exactly 0 degree, even if it is let's say 5 degree or for that matter 175 degree, even then I will call it equatorial orbit. And similarly, even if it is 95 degree or let's say 85 degree, I will call it polar orbit. It has to be closer to pole, it has to be closer to equator. But should be very clear that most of the orbits will be inclined. Their inclination will be 40, 50, 60, 70 or 120, 130, 140. You had a question. So we have to start with a reference point. Measurement का हमेशा एक ही तरीका होता है, that we have to decide a reference point. The question he is asking is that how do we decide which side of the plane we are measuring? So we simply have to decide a reference point. So for example, if this is my reference point, if this is the plane and I have जो satellite का orbit है, this is one plane, this is another plane, इसके बीच का जो है, I am not going to measure this angle. जैसे ये तो simple सा हमने third fourth में भी पढ़ा होगा, that हम दो line के बीच का जब हम angle measure करते हैं, तो clearly लिखा होगा वहाँ पे कि हम कौन सा angle measure कर रहे हैं. हम ये angle measure कर सकते हैं या हम ये angle measure कर सकते हैं. But this will be a proper convention that we go, let's say for example in this case anti-clockwise, and जो भी anti-clockwise measurement वो acute होगा या obtuse होगा, उसके हिसाब से हम decide करेंगे ये acute है या obtuse है. Yes. No, not at all. Because for either of this side, our measurement is always simple, that I'm going to move anti-clockwise. From equatorial plane, I'm going to move anti-clockwise and I decide what is the angle. Right? Simple. Yeah. Yes. हम इस पे हम आएंगे हम, और बिल्कुल सही बात है कि सारे तो क्वेश्चन इनका ये है that if we have to launch a satellite into a particular inclination, it's not that difficult. We just have to send our rocket in that specific direction. The answer is, of course, the answer is yes, that we have to first take care of our own motion. We are part of Earth system. We have to first take care of that, and then we have to go to the desirable motion. I will come to that, don't worry. So equatorial, polar, inclined orbit, this is clear. But now I have actually a very important point here. That polar orbits, in fact, I have a question here for you. That let's say that I want to attain a height of 600 kilometer around equator, and I want to attain a height of 600 kilometer around pole, from north pole to south pole. I have to use a rocket, of course. Will it be same effort? Effort का मतलब यहाँ पे है consumption of fuel. Will it be same amount of fuel in both equatorial and polar? So if it will be more, then where it will be more and why it will be more? So where it will be more first? Okay, so in polar orbit it will be more, not equator. Polar orbits are little difficult, not huge difficult, but polar orbits will require more consumption of fuel compared to equatorial orbit. But that is not the important question. The important question is that why would that occur? Why would polar orbit require more consumption of fuel? How, so that is same in case of both equatorial and polar orbit? Sorry, take this. Okay, so the second part, you need to explain that in a more simpler form, and that will be more correct. The first part is not correct. You may think that this is because of the shape of Earth. Earth has a geoid shape. Earth is not a perfect sphere. हम सबने पढ़ रखा है that Earth, ये जैसे globe है, हमने इसको perfect sphere बना रखा है. But we do know that Earth is not a perfect sphere. Earth has a bulge on the equator, and it is little bit flat on the top. So you may think that polar orbits, because it is little bit flat there is a bulge on equator, maybe there is more gravitational pull. Nothing to do with that. So why polar orbits are difficult to achieve? That has something to do with Earth's rotation. In fact, let me ask one more question here. Let me ask two questions. First question is that I have to fly from New Delhi to New York, let's say. Then why don't I just go few meters above Earth, wait for Earth to rotate, New York to achieve, and come down on the ground? Why do I have to literally fly from New Delhi to New York? Why simply I do not go at few height and just stay there, use airplane fuel, and wait for Earth to rotate back, New York to achieve, and land here? Why don't we do that? And in fact, let me ask one more question. Then I will come back to this question. That imagine I am in a truck. This truck is moving with constant velocity v. I am assuming that this road is very smooth. There is no jerk on this road. And this truck is moving on this very smooth road with constant speed in exactly straight line. No change in direction with velocity v. Let's say that I throw a ball with some speed u here in vertical direction. I have a question that where this ball is going to fall. Ahead of me, behind me, where? It will fall exactly in my hand. It will not fall behind me. It is going to fall exactly in my hand. Now why it will fall exactly in my hand? Simply because even though I threw that in vertical direction in my frame of reference, for an object who is, think about an object who is stationary on the ground, what that object will see? That this ball already had a horizontal motion with velocity v. I did not need to give that horizontal motion. It had that horizontal motion because it is part of a moving frame of reference. इसको समझना बड़ा आसान है. I had first-hand experience with it. I came to Delhi for the first time in 2006, I remember. I was staying at my cousin brother, and I was on a DTC bus, and bus का stop नहीं था वहाँ पे, but the driver slowed down. I came down from the bus and immediately fell down. So driver had not stopped the bus, he had slowed it down. So why did I immediately fall down? Simply because when I kept my feet on the ground, my feet immediately came to rest, but I still had that motion of bus. Now, I was not moving inside bus, I was part of the bus, and because of that I had that momentum of the bus. So my feet immediately came to rest because of friction, but my body still had that momentum and I fell down. Right, that is why a very simple advisable thing is कि don't do that, but if you have to do it, then you keep walking. आपने सुना होगा ना, अगर बस मान लो आप you keep walking, you coming, इंडिया में जुगाड़ करना पड़ेगा आपको, रोके बस ड्राइवर जरूरी नहीं रोक दे आपके लिए, तो आपको you have to keep walking here. Or another question, that I jump here, let's say I jump here, I'm coming back on the same point. Why am I coming back on the same point? If earth is rotating below it, we just have established, we know this, बचपन से हम यही पढ़ते आ रहे हैं ना, that earth is rotating really fast, by the way. Earth completes one rotation in 24 hours. So if earth is rotating below me and I am jumping down, why am I coming on the same point? Why don't I go to some other point if earth is rotating below me? Simple. The reason is very simple. Because we are also rotating. We are part of earth system. We have that earth's momentum. We carry that earth's momentum. Earth ka jo bhi motion hai, we carry that motion with us. And it is not just us. Turns out it is entire atmosphere. So not only earth is rotating, the entire atmosphere up to few height is rotating. So the reason why I have to fly from New Delhi to New York, because that airplane also has that earth's motion. Now to stop that motion, the amount of fuel and air, so for example, first an aeroplane has to go at very high altitude. It has to generate lot of thrust in opposite directions so that it can overcome the momentum of earth. Then it has to wait for earth to rotate and come down. The amount of fuel it is going to consume, and the fact that it has to cross atmosphere, it needs to carry the enough oxygen, pressure requirement, all of that will be so expensive that it is better to simply fly from New Delhi to New York, or for that matter New Delhi to any part of planet. It is always simpler because you already have so much of motion that you cannot overcome that motion. You are part of this system. Similarly, in this particular example, even though I gave that vertical velocity, this object already had a horizontal velocity, and it will be a very simple calculation to show that the amount of distance this point will travel, the same horizontal distance will be traveled by this ball. It's not a very difficult calculation. The point here is that if I assume that this truck is moving in a straight line, if I remove air drag, idealistic assumptions are there, then this ball is exactly going to fall in my hand, simply because I already had this momentum. Now what has that to do with the question I asked earlier, that why polar orbits are more difficult to achieve? So isko bhi samajhna आसान है. Earth is rotating on its axis. We have studied that. I am assuming this vertical axis, although it is at 23.5 degree from the vertical. Now, this point here on earth is moving in a circle of radius r. This point is also moving in a circle, but it is not the same circle. It will not be r, let's call this smaller. And this point is also moving in a circle, but now it is moving in a smaller circle. Now every point on earth is completing one revolution in 24 hours. So if I have to, one complete revolution basically means 360 degree. All points have this angular velocity or angular speed of this 360 degree divided by 24 hours, all points on earth. But now look at the linear speed. This object here, or this point here, traveled a distance of 2 pi r in 24 hours. 2 pi r is the circumference of this circle, and this point here traveled a distance of 2 pi small r divided by 24 hours. This speed is clearly less. So speed on equator, because earth is rotating on its axis, because of that Angular speed is same for each and every point on Earth. But the linear speed, that speed which you calculate by dividing distance from time, that linear speed on equator is very, very high. On pole, it is not very high. In fact, just at pole, it will come to 0. It will be about 0. So now imagine a rocket which has all of its Earth's momentum as it started flying. It has to overcome that Earth's momentum, and it has to now change its direction in a way that it launches a satellite into a polar orbit. Versus if I have to go into equatorial orbit. Think about equatorial orbit. I am actually getting an assist from Earth's rotation. If I'm launching something from equator, or if I'm launching something around equator, I already have a help. I already have an assist from Earth rotation. I'm not starting from 0. I already have some motion which is because of Earth's rotation. But if I have to go to polar orbit, I had some motion which I had to first overcome, and then I had to go in some other direction and launch that satellite. To overcome that, I need to consume energy. And इसको समझना basic life में आसान है. You go into a 200-meter race in a straight line, and go into a 200-meter race, go 100 meter and go back 100 meter. Those who have done running, they will know that doing this is much more difficult. That you go 100 meter, stop yourself, change the direction, and come back. That will require more effort compared to going to 200 meter directly in one straight line without stopping. So even that stopping leads to consumption of energy. You are running very fast, and then you have to stop yourself. That will require consumption of energy, and that will require, in fact, you, even though you are traveling exactly same distance, in the second scenario, 2 and 4th, that will consume more energy. So similarly, a rocket has to consume more energy because it has to first overcome its own motion. And why it has its own motion? Because it is part of Earth system. And then it has to change its direction in a way that it can launch a satellite into polar orbit. Versus if it is in equator, then it does not have to do anything like that. It is actually getting an assist from Earth's rotation. The difference will not be very huge though. I should be very clear here. But nonetheless, there is a difference. And now you can also answer the question that why do we launch our satellites from eastern coast, not from western coast? India में हम कहाँ से launch करते हैं? श्रीहरिकोटा से, हम सबने पढ़ रखा है. That we launch from Sriharikota, somewhere here. And we launch towards east direction. Any of the launch, आप जाके उसका trajectory देखना, there will not be a single launch. तो east direction में launch करने का significance क्या होगा? Why are we launching rocket in east direction from eastern coast? Earth rotates from west to east. हमने तो पढ़ा है ना, स्कूल में पढ़ा है हमने, that Earth rotates from west to east. So if I launch a rocket towards east direction, then I'm not opposing my own, I'm not opposing Earth's momentum. You can ask a question that why not east direction from western coast? That is also there. That is also possible, and here also I'm not opposing Earth's motion. The problem is that rocket is launched into stages, and those stages fall down on the ground. I will be talking about that in perhaps next to next class. I do not want that main land to be affected here. I do not want that rocket के जो fragments है वो यहाँ पे गिरे. So that is why we will choose eastern coast and we will launch a satellite towards east direction. जो भी country जिनके पास western coast और eastern coast दोनों हो, आप जाके देख लेना दुनिया भर के जो rocket launching stations होंगे, they will be on the eastern coast side. Countries who do not have that or who do not have any coastal land, they have to compromise. Either they have to choose rocket launching station in desert areas, or they have to send a satellite towards west direction and they will have to consume more fuel, or they will have to rely upon some other rocket launching station in some other country. That will require good relations between countries. But the point is that if a country has both eastern and western coast, for example such as India, then in such cases often we will use eastern coast, and we will launch our rockets towards east direction. The reason is very simple, because Earth is also rotating from west to east. So why polar launches then? So my first question here was that polar launches are little bit more difficult compared to equatorial launches. But nonetheless, polar launches are so important. Think of one of the ISRO's rocket. It is called PSLV. What is P here? Polar Satellite Launch Vehicle. आपने पढ़ा होगा PSLV के बारे में. PSLV is Polar Satellite Launch Vehicle. So polar orbits are so important that we have named a rocket after it, that we use PSLV often to launch satellite into polar orbit. So what is so unique about polar orbits? I will come to that part, but first अभी ये लिख लो पहले तो आप. Yes. Sorry, how? Because it is moving very fast. If I am already around equator, then I have lot of energy because of the fact that I am part of Earth system and Earth is rotating really rapidly. So that is why I gave the example of that truck here. That I threw a ball from truck in vertical direction, but even though it is going to come down in my hand, simply because it already had a horizontal momentum. I did not give it. That it already had because it is part of a system, which in this case is truck, and that truck is moving in horizontal direction. So equator already is moving very fast. अभी हमने mathematics करके देखा कि why equator is moving very fast. We just did this calculation. So since equator is moving already very fast, and it is rotating from west to east, then in such case, if I launch a satellite, if I launch a rocket in east direction, in equatorial direction, in equatorial plane, then I'm getting lot of assist from Earth's rotation. In case of polar orbit, I'm not getting that assist. In fact, in case of polar motion, I first have to overcome my own momentum. I already had energy, which I need to overcome. I need to change direction, and then I have to go to polar orbit. And that will consume fuel, some extra fuel. Yes? No, it is not possible. We always and always will require revolution. बिना revolution हम एक जगह park करने का मतलब ही नहीं है. Park, अभी देखो कोई भी चीज fixed, जैसे आपका जो question है, it actually goes to a very fundamental question in physics. That is there something which we can say that it is at absolute rest? There is nothing like that. So कोई भी चीज absolute rest में नहीं है. हम बस कुछ चीजें कर सकते हैं, which I am going to discuss. Don't worry. Write down few things here. Satellites in polar orbits. Satellites in polar orbits. Polar orbits are more difficult to launch. More difficult to launch than equatorial orbits. Than equatorial orbits. Because in polar launches, rockets do not get assist, because in polar launches, rockets do not get assist from Earth's rotation. From Earth's rotation. Also, launching stations are generally situated at eastern coast. Launching stations are generally situated at eastern coast. And rockets are launched towards east direction. Rockets are launched towards east direction. Because Earth rotates from west to east. Earth rotates from west to east. West to east. Now let me come to this last topic in today's class. Why polar launches then? Why polar orbits are useful? And that has again to do with Earth's rotation. Imagine for a moment that Earth is not rotating on its axis. In fact, let me ask one more question. Why is Earth rotating on its axis? I have a question here that why is Earth rotating on its axis? We know why Earth is revolving. That is, we just have established that has to do with gravity. That Sun and Earth के बीच में gravitational pull है, which allows Earth to revolve around Sun in a stable orbit. But why Earth is rotating on its axis? Sorry? I will give you 4 options. Answer is either of these 4 options. D you can eliminate. I just told you that that is not the reason. Gravitation is not the reason. Out of 3, which will be the reason? A, B, C. The answer is A here. Earth rotates on its axis because that is how it was formed. Earth was formed from dust particles which accumulated because of their own gravity. It was formed as a gaseous giant. That gaseous giant was rotating very, very rapidly on its axis. In the course of time, as it lost energy, because outer space is very cold, Earth is very hot, it lost energy, that it cooled down, and surface has become solid, so that life is now possible on planet Earth. But nonetheless, you did not have an external torque which can stop Earth's rotation. I'm using a word here, torque, not force. In case of rotational motion, force से ज़्यादा important जो parameter होगा वो torque होगा. What is torque? अब torque वैसे तो we need to go into mathematics of it, but you can appreciate the significance of torque. Imagine that I have a door here. I try to open that door. This is the axis where this door is hinged. I try to open this door at this point by applying some force F, and I try to open this door at this point by applying the same force F. Where it will be easier to open the door? At the corner point. It's very simple. That corner पे door को open करना ज़्यादा आसान है. Force is same, but इसको open करना ज़्यादा आसान है. So clearly, it is not just force, but also the distance which I have applied from that axis of rotation, which plays a very important role कि rotation कितना simple होगा या कितना मुश्किल होगा. So the same role force plays in case of, let's say, motion in a straight line or motion in a circle. The same role is played by another parameter which we call torque. And torque is vector product of distance and force, but I am going to not use the word vector product. आप ऐसे समझ लो कि distance, the perpendicular distance from the axis of rotation multiplied by force, that parameter is called torque. And now Newton's laws of motion accordingly change in case of rotational motion. In case of normal translational motion, motion on a straight line, what was Newton's law? First law was that if there is no external force, object remains unaccelerated. The same law in case of rotational motion becomes if there is no external torque, then object का जो angular acceleration है, that will remain 0. Second law, rate of change in momentum is equal to force. In this case, it will be rate of change in angular momentum will be equal to torque. There is a parameter called angular momentum. And every torque again equal and opposite reaction, we can use that. So Newton के जो laws of motion है, they change. So if you do not have external torque, then your rotation will not be affected. So the law of inertia है, that changes in case of rotational motion. And on Earth, you do not have external torque. You had some external torque. There was an object which collided with Earth, which led to formation of moon. That must have changed the rotation of Earth. But after that, as far as we know, Earth has not been affected by some type of celestial collision or some external torque which can change the rotation of Earth. So the correct answer in this question is A. It is because of law of inertia, that Earth was always rotating. That is how it was formed, and even today it is rotating, and there is no external torque here. So coming back to my point, that why polar orbits? So for a moment, imagine that Earth is not rotating. Now in such case, imagine an Earth observation satellite which I have launched at the height of, let's say, 600 kilometer. The earlier example which I gave you, that I have launched a satellite at the height of 600 kilometer. This is Earth. I have launched a satellite in equatorial orbit at the height of 600 kilometer. This satellite, maybe it will be able to observe this part of Earth really well. I told you कि हम जितना पास में होंगे, जैसे मान लो in my experiment, I have a satellite which is revolving at, let's say, 600 kilometer. It can observe a small strip around Earth. It cannot observe this part, it cannot observe this part, it can only observe a small strip around Earth. Now let's say I have a polar orbit, but Earth is not rotating. Then this satellite will observe this small strip around Earth. So in a polar orbit, I have a satellite which will observe this part of the Earth. In an inclined orbit, I have a satellite which will observe this part of the Earth. But the fact that Earth is rotating is blissful for us, because now satellite is revolving in polar orbit, but Earth is rotating below it. So for example, let's say that in the very first rotation, satellite was revolving above Delhi. But the next time satellite came back, Earth has rotated a little bit. This satellite is observing now some other part of the Earth. In the next orbit, Earth has again rotated a little bit. It is observing other part of the Earth. So by being in polar orbit, it can observe each and every point of Earth, which is not possible even in equatorial orbit right now, given the fact that the Earth is rotating. Now Earth is rotating, I have a satellite in equatorial orbit at 600 kilometer. वो तो अभी भी यहीं observe करेगा. It cannot observe beyond that. But a satellite in polar orbit, in each and every orbit as it revolves, it is observing some other part of the Earth. So it can observe each and every point of Earth. That is the beauty of polar orbits. Another benefit of polar orbit here is that it gets to observe polar areas. No matter how high I go around equator, I cannot observe polar areas. And by the way, if I go very high, my observation in any case will be affected. So if I am very close to pole, and in geography classes, it will become very important that why observing polar areas are very important. You already have some idea. You know about melting of ice, global warming, थोड़ा बहुत आपने पढ़ रखा है. You know about its impact on planetary wind system or ocean circulation system. All of that will be discussed in more detail in environment classes and in geography classes. But the point here is that we need to observe changes which are happening at polar areas, because those changes play a very important role in the entire climate system of Earth. And that is not going to happen in any other orbit. So why polar orbits? Despite the difficulty, two reasons. First, I get to observe each and every point on Earth, and second, I get to observe polar areas. आप लिख सकते हो? Polar orbits are very useful. Polar orbits are very useful. There is a question. Torque के लिए दो opposite forces चाहिए, अभी ये उसको couple बोलते हैं. And that is a very specific type of torque जहाँ पे दो opposite forces चाहिए. Torque can occur even with one force as long as you have some distance from axis of rotation. The torque you are describing, that is called couple. Anyways, write down few things here. Polar orbits are very useful because as satellites in polar orbit revolve, satellites in polar orbit revolve, Earth rotates below, which allowed satellites to observe, each and every point on Earth, Also, in polar orbits, we can observe changes happening at poles. We can observe changes happening at poles. And these changes play an important role in Earth's climate system. And these changes play an important role in Earth's climate system. By the way, अर्थ पे टॉर्क नहीं लग रहा है. मेरा जो पूरा पॉइंट ये था कि अर्थ पे टॉर्क नहीं लग रहा है, जिसके कारण जो अर्थ का रोटेशन है दैट इज नॉट चेंजिंग. अगर अर्थ पे टॉर्क लग रहा होता, देन डिपेंडिंग अपॉन टॉर्क का डायरेक्शन क्या है, दैट रोटेशन वुड हैव ईदर स्लोड डाउन और ईदर वुड हैव इंक्रीज्ड. I talked about equatorial orbit. This is what I was discussing, that even though that individual distance may differ, the sum of those two distances that will be same. This is Kepler's second law, don't worry about it. This is what I was talking about, that you get escape velocity at 11.2 km per second, more than that. At lower speed you fall down, but at some speed you find a stable orbit here. And if there is nothing which is going to oppose that motion, you get to remain into that stable orbit. And this is what I was talking about, a satellite revolving around Earth. There will be a point where satellite will be closest to the Earth. I will call that point perigee. And there will be a point which will be farthest away. I will call that point as apogee. And this is what I meant when I used the word equatorial orbit, that red orbit which you see, or polar orbit, or that low inclined orbit which is between 0 to 90 degree, or if this agar ye idhar hota, so that will be high inclined orbit. And this is what I meant when I talked about the significance of polar orbit, that small strip which you see here, that there is a satellite which is observing that small circle which you can see in this orbit. But the next time it came, Earth has rotated a little bit. So for example, in this case, it was observing, let's say, the eastern coast of North America. But in this case, now it is observing somewhere the planar area of North America. In the next orbit, it is going to observe the western coast of North America. So by being in polar orbit, a satellite gets to observe each and every point on Earth. And that is why polar orbits are very, very useful for Earth observation. In next class, I will complete this discussion about types of orbit. And I will also start or hopefully complete types of satellites and their applications. Okay, class, just a minute, that's a very important question, just 1 minute. There is a question here that some scientists have pointed out Earth's rotation being slowed down or fastened up. आपने कभी बचपन में स्विंग पे झूले हो गए आप, राइट? तो एक टाइम के बाद यू रियलाइज्ड कि स्विंग पे झूलने के लिए आपको किसी के पुश की जरूरत नहीं है. Just by folding your leg and stretching your leg, you kept increasing your angular speed. That is called conservation of angular momentum, right? So for example, if I sit on this chair and let's say for example, I rotate on it, and I can change my angular velocity. Let's say I have two dumbbells in my hand. If I fold this hand together, I will start rotating very fast. If I stretch my hand, my rotation will slow down. This particular phenomena is a consequence of what we call conservation of angular momentum. If there is no torque, then angular momentum will be conserved. Now question was that Earth's rotation is slowing down or fasting up. It will happen if there are some fundamental changes happening in Earth system itself. जैसे मान लो हमने कहीं पे एक डैम बनाया और उस डैम से हमने क्या करा, 1 मिलियन लीटर हमने उस डैम के अराउंड पानी स्टोर कर दिया. So suddenly we have accumulated lot of mass at a particular point, and yes, that can fasten or slow down depending upon what type of change that is happening, the Earth's rotation. So if there are internal changes happening either by human beings or because of some natural factor, then yes, from time to time that rotation can speed up or slow down a little bit. Okay. Yeah, that can change. So another question is that the asteroid impact which occurred, which led to extinction of dinosaurs 65 million years ago. Yes, that could change. That could change Earth's rotation, right? I will see you guys in the next class.